3 coplanar points, and bam, there's the radius of the Earth.
On the level.
The way I phrase it is a monument to the curvature of the Earth. It really
totally
is.
agree.
Level.
It really
totally
is.
agree.
Level.
And bam, there's the radius of the Earth.
This water level test that I've proposed with the water
Go right
levels.
ahead. Yeah, go right ahead. Let's. I'd like to see all methods and all technologies poured into your pissy little 400-meter water level, which will absolutely show 3 millimeters of arc at the middle. Yeah, or whatever the number was. I forget.
It will show 3 millimeters of arc. Do you say?
I think so, or whatever that number was. I'm poorly remembering.
Okay.
But yeah.
Good. It's there to be measured. That's all I want. That's all I wanted. Yes. Thank you. Thank you, Larry.
Yeah. And when you find it, you'll know that it's accurate. And when you don't find it, then we're wrong.
But you do measure straight lines with your line of sight. And do you often use an a theodolite for establishing elevation?
I do, because I work at multi-mile. But when working at a few hundred meters, yes, I use a regular conventional spirit level.
A spirit level? What, not an auto level?
Correct, because mine is 65 years old.
So you use a spirit level?
Yes. A geodetic grade spirit level.
Wow, that sounds nice.
It's expensive.
Have you ever seen a Dornagon?
What?
Have you ever seen a Dornagon?
I don't think so.
No. It's a conceptual mind shape. Shout out Dawn. I mean, genius. It's a conceptual mind shape that is made up of 2 or more shared straight line segments. Much like the horizon. Right? Because that is, every time you look at it, no matter where you look, it's a horizontal. And you just add all of those straight horizontals up, and you can imagine it's a circle. See, this is a conceptual idea of the water levels all being straight lines and having shared straight line segments, but also you being able to imagine them being a circle.
So we need to find a way to tell, are they a straight line or are they curved?
Yeah, that's exactly it.
You can't use them as a straight line and tell us, you see? No.
I calculated the elevation, and then I checked my work against the published, and I was within a couple of feet of what they said, and I did it from miles away. Yes, that's what I did.
Okay. It just is a hobby, right?
As a retired land surveyor that happened to have purchased a whole bunch of very high-order equipment, and a constant elevation is water seeking its own level. And yeah, that's all those points at the meniscus and all of those uprights will form 3,960 mile arc, radius arc. And if you sight from the beginning point to the end point, you should see the ones in the middle a little bit higher, just like Wallace did on the Bedford levels back in 1870, whenever.
Did you just say level is a circle?
No, I said level is a constant elevation of 3,960 mile radius of the Earth, of the planet, because the planet is in hydrostatic equilibrium.
But that's how you describe a circle, right?
Okay. Yeah.
Constant distance from a center.
The surface of water is a three-dimensional surface with a radius to the center of the Earth. And in your graphic, when you drew the red arc and the blue arc, you mistakenly did not draw them concentric.
Did you just say a hydrostatic equilibrium is a circle?
Is the planet, yeah.
So your plane curves, Bearded Devil. You need to work on that.
Nonsense to be off the jump.
Good, look it out. All right, let's start officially now. Look at that. Before top of the show, Sean Smith is asking, What's a super chat with a $2 super chat? Thank you, Sean Smith. Welcome, guys. Thank you for coming in right on time. Top of the show. I already told the people on YouTube if they have any question, comment, concerns to tag me or throw me with $1 or 2 super chat. And every half an hour, I will be stopping you to tell you, we'll read a few comments and questions from the YouTube chat. And you guys have the floor. Bev Try Thinking and his crew. Right now, we are joined by Beard the Devil, Bev Try Thinking, Bogov, Shaik, Cleary, Jeremy, Melman, Merle, Rob, and Stacy B. Now, Bev, Try Thinking, we're going to have big time microphone priority because this is going to be his presentation. He wants to do it interactive. So anybody's going to be server muted unless anybody interrupts not anybody that doesn't belong in the on the level presentation crew. If you interrupt any point, you will be server muted. And then Bev Try Thinking, thank you for coming. You got the mic.
Okay, thanks for having us. Is Larry here? He's not here, is he, at the minute?
He's not here yet.
No.
He usually join in within half an hour in the show, so hopefully he come in.
Okay. Well, do you want to wait for Larry to come? Because I was hoping that Larry could go through this with us, but maybe we might be able to have somebody else to.
Maybe if you want to start, I mean, maybe Beard the Devil, Bogov, or Shaik want to jump in, and
Jose,
Yep.
I noticed that Bearded Devil is here. Maybe we could spend this first little half an hour or so going over his little article that he posted.
Oh, that'd be good. I just need to finish my tea.
In mathematics, not in reality, it talks about plane curves in mathematics. Can we apply that to reality somehow, Bearded Devil?
Do you want to repost that article, Bearded? If you got it, or anybody repost it on the Daily Boom. So what I'm going to do is I'm gonna share my screen, and whenever Bev is ready to begin with his stuff, then I will switch over. To his screen presentation, whether it's camera or screen share. Okay. Damn, we got a bunch of people. Hell yeah. Okay, let me see if that will go through. Hopefully, go through YouTube. Working on it. There you go. We got it up. Okay, now I gotta share this Wikipedia article, and it's up. Plane curve. You got the floor, gentlemen.
What's up?
Yo, is anybody going to talk about the article? Bearded Devil, are you there?
Don't go crazy, not all at once.
Well, I would just point out that it does say plane.
Somebody to actually say what the problem is, because so far I'm just hearing, oh my God, there's an article.
It says plane, Bearded Devil. You know, a plane is a two-dimensional surface, right?
Yeah. I know what a two-dimensional surface is. Thank you.
Okay.
Do you know that all surfaces are two-dimensional?
Apart from the three-dimensional surfaces. Yeah.
Oh, God. Nope. Try that again. All surfaces are a two-dimensional surface.
Okay, that's a nice claim, but everybody knows here that 2D is length times breadth. Just two dimensions.
Okay. Surface. Two-dimensional. All surfaces are two-dimensional. Unless
mathematical,
you can inform me
mathematical concept.
How a surface has a height. Or width, if you will. However you want to define that. A depth. How does a surface have a thickness?
You want me to take this one, Bev, or?
It's a mathematical concept.
It's pretty simple, really.
In reality.
Yeah, go ahead, Jeremy.
Yeah, an object such as the surface.
It hurts. No, I'm waiting on Bev to explain to me how a surface isn't two-dimensional, or how all surfaces are not two-dimensional. How about that?
Yeah, let's take the surface of a sphere, for example, right?
Yep, still two-dimensional.
Yeah, you've got this. So you've got this spherical object.
Still
the surface of
two-dimensional.
it. Right. You have
The
this. So which dimension
is
are we missing when we have the surface of a sphere? It's a sphere shape.
Yeah, got it.
All right. So we got length and height and width to it.
You don't have all three components on the surface.
Just hold the basketball. Hold the basketball in your hand. Imagine that you're holding just the surface. So it's going up and down, right? You've got height.
You ever peeled an orange before?
Sure, the surface of it is three-dimensional.
The surface is
Obviously.
not three-dimensional.
Yeah, it is.
The surface is not three-dimensional.
Yeah, it is. It's a mathematical concept, okay? Your two-dimensional surface of a sphere is a mathematical concept. It doesn't exist in reality. In reality, when you peel, in reality, when you peel an orange,
Bearded, not yet. They have microphone priority, bro. If they want to keep talking, I mean, we gotta lay back, man.
In reality, when you peel an orange, you have a three-dimensional surface, right? It's undevelopable on a flat plane.
It's not. Is a piece of paper a three-dimensional surface?
Show me the piece of paper.
Dude, is a piece of paper a three-dimensional surface?
In reality?
It's a three-dimensional object, yes.
Yeah, I didn't say object. Please pay attention to the terms I'm using. Is a piece of paper a three-dimensional surface?
No.
What's the difference between a piece of paper, the surface of a piece of paper, and the surface of an orange?
The plane.
What?
A sphere is a
plane.
Go ahead, Claire.
Try that again.
Oh, he's speaking like he has authority or something. Try again.
It's not,
what are you talking about?
Authority.
No, you don't. You don't have authority.
He has Bearded Devil has a condescending tone, and he's an asshole. Like he really is.
He really is. Especially when I'm hearing individuals who understand the concept that a surface of a piece of paper is not a three-dimensional surface, and yet can't connect the dots between that and an orange peel.
Listen, Clary just told you.
Go ahead, Jeremy.
Clary just told you the surface of a sphere is a non-developable surface. Do you know what that means?
Go ahead. Inform us.
Do you know what it means?
Inform us.
Do you know? Because you're talking about shit like you know what you're talking about. So I'm asking you, do you know what this is?
Clary, elucidate.
We're asking you. Do you know? You're here telling us what it is and what it isn't. So do you know what a non-developable surface is? Since you think this can be a 2D surface. You have no idea what you're talking about, and this just goes to show it.
Okay.
Yeah.
You got confused with the orange peel. I understand.
Oh, you got confused with a developable and a non-developable surface.
Do you live on an orange peel?
At this point, it might as well. Because so far, someone
who's try to frame it now.
I would tell you about it, but you don't know what a non-developable surface is. You're ignorant. You're ignorant in this area that you're talking about.
Do you think that that's going to work with me?
You're ignorant. You don't even know what you're talking about.
Really?
Well,
are you sure?
There is some
showing
time.
Everyone on this panel, you're ignorant about what you're talking about because you don't know what a non-developable surface is.
I know.
There is.
Hold on.
Does anybody, Bearda, you don't? Anybody want to hear the Rumpus explain it?
No, I don't want to hear Rumpus explain it.
No.
Yeah, go ahead,
Okay.
Rumpus.
Yeah, it's just simply, it's got nothing to do with.
But hold on, yeah, Rumpus. Bev say he don't want to hear you, but clearly
go on then. Let's hear it. Let's do a quick one and then we'll start. All right.
An idiot. Who cares?
No. But the Rumpus, yeah, it's very important because they have the microphone, priority, and it is up to them if they want to hear it or not. So, yeah, and don't insult anybody, Rumpus, because you'll be muted for the rest of the show.
And no monologue. Just
well, he's an idiot. I'm sorry.
Oh my God.
Give us a quick definition, or you're gone.
Right, the developable surface has got nothing to do with whether it's two-dimensional. It just means whether you can do something like map a surface of a sphere onto a flat plane, which you can't do. And Bev uses this argument to somehow the difference between 2D and 3D. He doesn't understand they have nothing to do with one another.
That's good, short. Yeah.
Why is it undevelopable?
Wow. Rumpus here to save the day, obviously.
Yeah, so it's got nothing to do with the 2D, 3D thing.
That's a little bit
advanced. Bearded Devil is absolutely right. I mean, just imagine the reason you call it a surface means you only need 2 coordinates to cover the whole surface. That's what makes it two-dimensional. And as he said, the thickness, you would need 3 coordinates. But if you only need 2, then it's two-dimensional.
Thank you. Thank you.
Jesus Christ.
Why is it?
Thanks, Rumpus. I don't know what I'd do without you in my life. Thanks, mate.
You'd be even more stupid and ignorant.
Oh my God! Yeah, that's it. Yeah, that's it.
Rumpus.
Thanks,
Why
Rumpus,
is it
for
undevelopable?
Thank you for playing, Rumpus.
No, you're going to
if something comes up off of that
you're
plane,
going off of a red herring. So nobody cares about whether or not you can cut it into a million pieces to make a complete shape. The fact is, the surface is still two-dimensional.
do you know what happens when something comes up off of that 2D plane
So
that you can't fit your sphere on?
Dude.
Okay, Jeremy, let me just help him out here for a second. So there's no elevation profile on your two-dimensional surface then, right?
On any two-dimensional surface.
Mm-hmm.
No accounting for elevation is what you're getting at, right?
Absolutely.
How would you be able to do that? It's a two-dimensional surface. You only have length and width. That's it.
But we do, but in reality, we do have elevation, right?
In reality, we still have two-dimensional surfaces.
You're not listening. You're not answering my question. You didn't.
You are a two-dimensional surface.
Let me try, Rob. Listen, Bearded Devil. Rumpus just told you can't put that surface of a sphere, you can't put it on a 2D plane, right? You
that
understand?
is not what the dude said. Try again.
That is literally what he just said.
Jeremy,
that's what a non-developable. So that's why I don't even know why we're talking about
no,
this.
It's
you don't
not
understand
what a
developable and a non-developable surface is.
That
why are you even talking about
change
this?
The fact that the surface is two-dimensional. It doesn't matter how many ways you want to do
why
that.
why it is three-dimensional,
Really?
but you don't understand what it.
Explain to me how a two-dimensional surface is three-dimensional.
It's not two-dimensional.
Please, Bearded, do not ask him to do what you are meant to be doing. He's asking you to explain it. Don't turn it round and just ask him. I mean, we do notice that sort of stuff.
Don't interrupt him, Bearded. Sorry.
Cheers, Jose. It's obfuscation, this, isn't it, Bearded?
Not obfuscation.
Like Jeremy's very correct. You do not understand Gaussian curvature.
Okay, no,
and
I don't
an undevelopable surface. Please explain.
That kind of shit shouldn't be able to fly. If I'm going to answer a question, you better let me fucking answer the question.
Wow.
I'm sorry about the cussing part.
Don't get too triggered, though, but carry on.
I'm not triggered. But you're not going to sit here and tell me that a two-dimensional surface it has three-dimensional characteristics because you're still missing that third dimension.
As you can look at a ball, Bearded. It's obviously 3D. The surface is obviously 3D. What you are doing is you are getting confused between 3D, 3 space, Euclidean 3 space with X, Y, and Z, length, depth, and breadth. You're getting that confused with a two-dimensional surface.
Hold up. Since y'all are worried about being able to cut up a shape,
I've not said anything about cutting anything up.
Yeah, well, freaking Jeremy is on that. So if you take a cube, right, or a box,
what a cube?
Let's switch it now.
Yeah.
A cardboard box.
Yeah.
It's on a sphere.
Yeah.
You live on a cube.
Full of two-dimensional shapes on the sides, right? 2D.
Is the surface two-dimensional?
Yeah, a square and a circle are two-dimensional figures. That's what makes them that shape. 3D is the other version, right? It's pretty obvious to anyone.
Hold up.
Apart from...
Hold up.
Go on. Hold on.
So you're giving an exception to other three-dimensional objects, but not a sphere for some whatever reason?
A sphere is 3D, right? A Euclidean sphere, in reality, is a 3-dimensional shape.
You're still not missing. You're still not really addressing what I
What
just
shape
said.
is the surface of a sphere? Please.
You said quite clearly that a cube has a two-dimensional surface.
Yes, it has squares. Has 6.
that really isn't
6
part of the
two-dimensional square surfaces.
Same thing if I sit there and say a tetrahedron.
It's poly. It's the flat, planar surfaces.
So if I keep going with all of those continuously in smaller and smaller and smaller flat surfaces, and keep going, at what point does it turn into a sphere, and then you'll accept the fact that it is a two-dimensional surface?
It's a planar flat. You've just said planar, right? At no point does it turn into a sphere because, guess what? A sphere is a surface of constant curvature.
Oh, man.
Yeah.
Again,
that's a boom.
Still a two-dimensional surface. There's no way.
No. There's a difference. A ball sphere in 3D, it rolls along a two-dimensional surface, which would be a flat, right? It wouldn't roll if it was 2D. 2D on 2D doesn't roll.
If a box can have a two-dimensional surface, then why can't a sphere have a two-dimensional surface?
Well, does a box roll?
Why does rolling have any? That's a red herring.
It's a flat planar surface against a flat planar surface. What
on the surface
do you not understand?
Of an object, what is that third dimension that you seem to be missing? Where is that third dimension?
A third dimension's in reality. It's the dimension you don't have on your two-dimensional surface of a sphere. See that two dimensions? See that?
Is it length, height, and depth? Is that the 3 dimensions?
If that's what you want to call it.
And no surface has that third dimension. That's the entire point. Not one single surface has that third dimension.
Well, this is a really good explanation of what we're doing here, isn't it? Because at the minute you're saying that 2D. So, are you advocating at the minute for the surface that you live on to be 2D? Is that what you? Because we're just saying that the reality that we live in is 3D. And we measure a vertical height, which is obviously a third dimension, using Euclidean geometry. Are you advocating for that surface to be 2D?
Every literal surface is two-dimensional.
Okay, I like it. You're sounding, you know what you're beginning to sound like here, Bearded?
I'm pretty
2D is flat, right? Do you think you see flat everywhere? All you see is flat everywhere. The surface of everything is flat. You might have become as obsessed with flatness.
That's not how that works either. You know that, right?
But you say 2D. You're the one advocating for 2D. Even the surface of a sphere you want to be 2D.
Dude, a sphere, a square, a fucking cube, a fucking any other shape, right? Any other three-dimensional shape has a two-dimensional surface. This is not something that's going to change because you don't like it.
Like squares and polyhedrons, right?
You're a three-dimensional object that has a two-dimensional surface. You yourself are that.
Do you know what like a circle, that's 2D, right? And a square, that's 2D. A triangle, obviously, that's 2D. Mm-hmm. Yeah, 2D shapes.
Yeah.
Right. Is a sphere a 2D shape?
It's a three-dimensional object with a two-dimensional surface.
Can I ask you one quick question, Bev?
Off you go.
I don't know how many times this can be repeated because that's exactly what it is. It doesn't matter how many ways you want to ask that question. Three-dimensional objects all have two-dimensional surfaces.
All right, hey,
Let's
Bearded
see.
Devil.
Yeah, who is that? Go ahead, man.
It's Cleary.
Oh,
Hey,
go ahead,
Bearded
Cleary.
Devil, is the Earth a sphere?
All I can tell you is that there are no.
Is that a yes or a no?
You're not
You can't
answering
tell
the
us
question.
if Earth is a sphere?
That was a non-answer, I think.
It
First
will
one of the
always be a
night.
non-answer.
What?
What the fuck?
Is the Earth a sphere, Bearded Devil?
I don't care.
So
Yes or no?
You can ask yes or no. The answer will always be I don't care.
Bearded
That's
Devil.
right.
Not moving on.
That's right.
Bearded Devil, can you walk and chew gum at the same time?
Sometimes I do.
Only on Tuesday.
That's a good one. Sometimes I do.
Did you say
You're not a
yes or no,
glober?
Bearded Devil?
You're not a glober, Bearded Devil? I thought you thought Earth was a
No,
sphere.
I'm not a glober. I mean,
Oh,
So you're a
okay.
flat earther. You're a flat earther.
Yeah,
Then.
welcome
I'm
to
not
Flat
a
Earth.
flat earther either.
He's a 2D earther. Okay, just don't push him.
Dinosaur.
Just
Not
2D.
2D earther. Dude, Bev, it doesn't help you. Unless you're going to show me somewhere in any of the mathematics or any of the actual Euclidean geometry that you supposedly understand, where it states that a three-dimensional object does not have a two-dimensional surface, I would love to know.
Yep,
Until
just
then,
did. Just wrecked you. Just
It
like
says-
Maybe
3
we should be
seconds ago.
not even close.
Maybe we should be talking to a real glober here. I mean, you got any real globers here, Jose?
Yeah, right now I'm doing, because you guys want to talk to Bearded
Why?
for a
Because
minute. It's up to you guys if you want to keep going with this. I don't see us in the chat. Nobody's seeing Larry Scott. Hopefully he'll show up. There's other people here. I don't know if you guys. Well, it's your call. I'm here to give you the floor to.
Yeah,
to do your
I'm
thing.
just making a brew, but I will be ready to go in a minute, though. No doubt there'll be somebody, but perhaps Bearded. He sounds like he's. I mean, if he's non-committal, he sounds exactly. You could bring Flip Flop in with us and go through
Angel
it.
of Attack, and Artrexis. They're also Bogov are here. Busa, Chaik, maybe.
Yeah,
They want to
it's
jump in
okay
when
with
the
about
Q&A.
2 people
Yeah.
when we go through this presentation. That's about.
Yeah.
that'd
Well,
be about
yeah.
right.
It's gonna be your microphone priority 100%, and then green light for people to answer the question. So one person will jump in if they want to answer and engage. Yeah.
What happens if nobody interacts? I'm just curious.
I'll interact. I'll go along
No,
because I don't want to leave it hanging.
Don't worry,
I'm
Bearded.
referring-
Don't worry, Bearded. There's some real globers out there that are going to want to interact.
Yeah, I'm
You
not.
can't even answer a simple question whether the Earth is a sphere or not.
Why would I need to?
Because.
What
Yeah, why?
shape do you think the Earth is?
Earth-shaped.
Earth? What the fuck does that mean?
There is no
Shaped like
Earth
dirt.
shape, for heaven's sakes, hun.
What's
That really bothers y'all that I don't really give a shit.
But if you don't give a shit, why are you here
do?
to defend it and talk about all this stuff
I'm
if
not.
you really
Dude,
don't give a
ask
shit?
anyone here. Ask anyone here. Does anybody have I ever defended the globe? Raise your hands.
Yeah, no. Bearded is always, well, from my point of view, Bearded, all the time that he's been here and supporting me. Thank you for supporting the channel. He likes asking questions and learning about flat Earth and other thing other than the globe. He likes learning about things other than the globe. That's kind of he likes doing that. I appreciate it. I couldn't do it because I was gonna try to somehow defend the globe or propose what I think, but he's hard to get what he thinks. He just wants to learn about flat Earth and other things other than the globe.
Bearded would be brilliant to
That's
come
from my
through this.
perspective. I mean, correct me if I'm wrong, Bearded, but that's what I see from you.
Pretty close. Yeah, it's a really simple position. There are no valid arguments for the flat Earth. You guys are more than welcome to engage in that discussion. 9 times out of 10, that doesn't happen.
You know why I say it's not flat, right? Because flat is a 2-dimensional surface, and it's obviously not a 2-dimensional surface. Although you were strangely arguing for that just earlier.
No, because
yes, you were.
I'm sorry, but that's a false equivalency. It's not. It doesn't work that way. All right.
Okay.
Every 3-dimensional object has a 2-dimensional surface. There is no way you can get around that.
Well, you
Saying
do
that
realize that a
it has to
flat
be
surface
flat.
or is a plane,
Yes, a
which is
flat surface
two-dimensional.
can have a flat
You just keep
surface
over talking if you want. Yeah.
because you're just repeating yourself.
Well, what is a plane surface? Is that two-dimensional?
Every surface is two-dimensional.
Is a plane a two-dimensional surface in mathematics?
I'm already saying this again. Every surface is two-dimensional.
You won't answer the question.
Brilliant. I know.
That
Yeah.
is the answer.
We're going to go through the thing. Is Larry here yet?
So
Larry?
again, what happens?
No, I don't see it. You want to do your final point, Bearded, because they're about to start with their presentation.
Oh yeah. One of the final points is I want to see what happens to this presentation when no one actually interacts with it. They just listen.
So, have you joined today to derail this in every possible way you can?
I haven't derailed anything. They were getting ready.
You sure?
He just said he was getting ready. Wasn't ready.
Oh, so you're the warm up act. The warm up act, right?
Apparently, somebody dropped my name.
Holy shit, Bearded.
I was watching
Nice.
on YouTube. I heard my name, so I was like, who wants to talk?
You were scaring me with that troll. That was intense.
Where are you getting a troll from?
I like Bearded as a troll. He gives me money when someone.
So just for my final thoughts on what happened, Bearded doesn't know what the shape of Earth is, other than Earth shaped, which is a ridiculous answer.
Bearded said all spheres are two-dimensional. When asked what shape the Earth is, he got real puzzling.
All right, guys, I'm gonna stop screen sharing. Are you gonna screen share or your camera something? Yeah.
Just setting it
Whenever
up now.
you,
It won't let me do the
whenever
camera.
you get
You've
it
got
set.
over 25.
Okay.
You've got a big room. You can't put a
shit.
camera
Yeah,
out.
okay.
It's all right though. I've got this. See,
All right.
to see
All
whether
right, let me
that's
share it.
good enough. Is it, or is my computer just fried? How's that? Hello?
Yeah, say that he just called Larry. He's working in a noisy highway, so Jesse is unable to join, but he gave Larry the heads up that the show. Larry is here too.
We
Cool.
see you, Bev.
Beautiful.
We see you.
Right on time to start the presentation.
We see you, Bev.
And we see your screen share. You're up, Bev.
Okay. Let me make sure I've got it on here. Right. So, who have we got? This because this presentation is a presentation from first principles to try and take everybody back to the most basics and run you through it as best I can. The first to start off is the cognitive dissonance. We have to go through this because I think Bearded Devil was showing us a little bit of it earlier. We always have to go through this because for people to know that you can duck out at any time. There's no need for you to act aggressively in this at all because this is just it's a process. So cognitive dissonance is the mental conflict that occurs when beliefs or assumptions are contradicted by new information. Unease or tension that the conflict arouses in people is relieved by one of several defensive maneuvers. They reject, explain away, or avoid the new information. Persuade themselves that no conflict really exists. They reconcile the differences, which is a bit strange. Or resort to any other defensive means of preserving the stability or order in their conceptions of the world and of themselves. It's a concept made from the 1950s, which sort of means that there's a conflict that happens from what you were taught or told or whatever that you've perceived to know for yourself, and this new information that conflicts with that information, right? And that causes your brain to do a little bit of a goes a little bit strange, and people react differently without, you know, like you've obviously seen it in people. It happens to all sorts of different people. So no doubt you can see the explain away or avoid new information and persuade themselves that there's not really any conflict, or they reconcile the differences, right? I think this is it's a state of mind that people are in at the minute. You have to realize that this is something that you may have been taught or may not have been taught, something in your youth that you hold, but you know the actual thing that you've been taught isn't there. There's nothing. It's frightening to some people, this new information. So if anybody thinks it might be too much, you can back out now.
This is good. Everything looks good on YouTube.
Yeah.
Sounds clear, looks clear. Yeah, you're a go, man.
Okay, right. Now, when we went through this with Louis the other day, he had a big thing to say about that cognitive dissonance. He agreed with it. So, do you agree that there is a thing, cognitive dissonance, and it does affect people? I mean, we're all affected by it. It's whether you're willing to notice that we are affected by it, or you think you're stronger than that. Are we all ready?
Ready to rock and roll. Yep.
Okay.
I'm all ears, man.
Who do we have going through this? And make sure whoever's going through it. Larry, are you ready to come through this?
Get a mic check there, Larry.
Yeah, I'm paying attention.
Okie dokie. And Jose, yeah, that's good. Right, so we start off. Step 1. First principles, a straight line. Straight line has no curvature. A right line has no curvature. A straight line is a right line. Become apparent in a bit. A right line, this is my definition, but I mean it's made from a few different places. I've had to add extra things to clarify the point that we make about this. This is the first step of the fundamentals. A right line is that which lies evenly between its extreme points. That is without curvature in any direction, being the shortest path between those 2 points, never deviating from that path. Now, this isn't a concept. This is a fact of reality and basic logic. Straight lines don't curve. Do we understand that as a basic starting block for us to go forward? I mean, disagree if you want, and we can go a bit further. But I mean,
I can. Straight line doesn't curve. Are we counting on elevation change?
Just a straight line. I mean, if you want to put it a straight line with an elevation.
Yeah, I can agree. Like, yeah, a straight line doesn't curve left to right. It can go up and down, but a straight line is a straight line. Yeah.
Well, that would be a sloped line, if that's what you mean. No curvature.
But if there's a very straight looking road, but it got these little up and downs, it's a drive straight, don't take the left, don't take the right, just drive straight. And it looks pretty straight, but it got up and down. Is it straight?
But this is, that I'm driving on? These first two are, because this is first principles, this is the basics of geometry. This isn't like roads and coins and things like that. Yeah. Footballs. This is just a straight line.
Larry shouldn't jump in there, and I run past him. Sorry.
What do you think, Larry?
2 points define a line.
Yep.
2 points in 3D space is a straight line.
The shortest path between those 2 points
Is a straight line.
Brilliant. No curvature.
If they're just 2 points in 3D space, like where I am on the ground to a radio antenna, I can see a straight line between me and that radio antenna. Yes.
Okay, no curvature.
Independent of any definition of the terrain I'm on or the planet we live on, right, from me, my observing instrument, to the red light on that radio tower, 18 miles away, straight line.
Okay. So we are just talking about a straight line, but I mean, we have
right.
a few quotes here. It's within the basics of Euclidean geometry and the basics of logic to start off with us, and this is one of the about the statements and all of that within the axioms and postulates. And it says, similarly, it is not possible to give a verbal definition of every word because we must already understand the words in which a definition is framed. An example from arithmetic is the impossibility of defining 1. Try it. That does not mean that you do not understand 1. An example from geometry is the definition of a straight line. Is there something we know better or is more fundamental on which a definition could be based? Right, so that means in order to deal with this as a concept, we need to have our elements that we use as building blocks, and a straight line is just that, right? It's what we go to. So can we agree sort of that geometrically a straight line is just the shortest distance between 2 points in free space, in 3 space, in Euclidean 3 space? Everybody could understand that, can't we?
Yeah. Just like the definition of 1. Yeah.
Okay, so then we move on. Once we've got the definition of a straight line sorted, a perpendicular. This is definition 10 of the elements. When a straight line standing on another straight line makes the adjacent angles equal to one another, each of the angles is called a right angle, and the straight line which stands on the other is called perpendicular to it, right? So you've got one straight line and another straight line at right angles to that straight line is called a perpendicular. Now, which one of those two lines is perpendicular doesn't really matter because they're both straight lines, right? They're both perpendicular to each other, and the fact that one of them is a straight line automatically comes with a perpendicular, right? Or series of perpendiculars. So, and the point of us saying it's a straight line as well is sort of, it's a proof that you need 2 straight lines in order to make an angle. And these are the right angles because all 4 right angles are equal when they are 2 lines at right angles perpendicular to each other. Would you agree with that? Or can you, or would you like to make a case that perpendicular has something to do with curved lines somewhere?
All right. Perpendicularity is right up there with the definition of 1. We all understand it.
Yep. Straight lines.
Perpendicularity.
Yep. I love it. It's a big word, that, as well. Get a good score. So that's sort of the proof of straight lines and angles needing 2 straight lines. The inclination of one to another is an angle, and they have to be straight lines.
Did Larry agree to that point, though, or?
Yeah. He said it was as basic as the 1, 2, 3. Right, the elements. It's a definition. You can't go messing about with that. 2 straight lines. So.
Hey, I just really quick. I want to let them know the panelists over here. It's 29 watching. I don't know what the capacity of people watching the stream at once are, but if you cannot see it, then open the YouTube watch page. It's like a 30 seconds lag, but it's pretty good because he's leaving the little slides for a little while. So if you cannot see it live on real time here on Discord, check it on YouTube live. Carry on, man.
Okay, well, they were the first 2. That was purely geometric facts, just to get the basics sorted. But this is right line geometry that we're going with. So we go into, now we turn into reality. A plumb bob. This doesn't normally take too much. This is if people are ever struggling about a straight line. A plumb bob is a perpendicle. A perpendicle is anything hanging down by a straight line. Plumb bob is a tool for establishing a vertical reference and used in reality daily by many people. And a vertical line, as established by a perpendicle or a plumb bob, is a straight line. You would agree, would you? Just basic facts.
Yeah, because it is parallel to the gravity vector at that location.
Okay.
And please don't stop for my comment on every one of your things. Go for a while or something. Maybe it's like you'll say something. Do you agree? You say something. Do you agree? This is going to get real tedious real fast.
No, we've only got 7 points here. Just that's all we're doing. There's no pressure, Larry. It's just anybody can answer, but I would like you to come with us. I mean, Jose, would you agree? Plumb bob, it's a straight. We call it vertical.
Yeah, plumb bobs are vertical. They are parallel to the gravity vector, and they point towards the center of the planet. Yeah, we got that.
Okay. Next one then. A level is a straight line on a horizontal plane. Level is a tool for establishing a horizontal plane of reference in which vertical heights differences can be measured. An instrument for determining whether a surface is evenly horizontal is from Latin, a balance level. That's what the level means. It's balanced. It's neither higher nor lower at either end. Would you agree with that?
Yeah. Level is with the point where water does not flow. It's equal potential at all points.
Yeah. Okay. Well, a straight line though, right? Level.
No, I didn't say that. I said equipotential because it's level at a constant elevation. Now, you want to talk straight lines, that's one thing. You want to talk about level as related to the surface of a body of water. Now you're putting in kind of a conflicting scenario there. So, no.
Horizontal.
Horizontal is a very local term. It is not extendable beyond a few hundred feet at human scale.
It is horizontal though, right? That's all we're going on about.
In a local sense.
Okay. So level is horizontal. And that is a horizontal is a straight line. So level is a straight line on a horizontal plane. You want to throw in locally at the minute. I mean, that's fine. We'll go along with that. But it is a straight line, right?
Yeah. Locally, a horizontal line being level within limits are close enough. Not exactly the same, but close enough.
Horizontal though, neither higher nor lower at either end of a straight line.
Then there again, you're limited by distance from the point at which you are level. So, yeah, if you go out a couple 100 feet, yeah, you're close. If you go
put
out,
a tilt on it. If you put a tilt on it, it's not level.
No, I didn't put a tilt on it. All right, I'm going to mute, and you can just go on.
Okay. So it looks like Larry's tapping out.
This is where Larry already got cog dis.
That was the cog dis, yeah. It's okay. I mean, that's fine. Who else? I mean, this is pretty easy, right? I mean, it gets easier. Would you agree, Jose?
Just get on with it, please.
Who is that? Mute that person, please. Jose, what would you say that level's horizontal? Can I proceed? Do we get an agreement? Although I think Larry sort of agreed, didn't he? Yes. Okay,
yes.
Now,
People, I'm sorry, you were muted because you talked in between. His Bev presentation. He didn't ask you a question because you rushed him and you spoke out of order. You're muted, and that's what's going to happen with every single person, unless you are from the OnTheLevel team, you know. So Glovers, if you interrupt, you'll be muted. Boom. I mean, what else to say?
Okay, now level and plumb are always perpendicular. As in, if a plumb bob is a tool that gives you a vertical, then perpendicular to that vertical would be horizontal, which is level. Would anyone like to disagree? Because we did just say earlier on, I know Larry just fried out just earlier when level was a straight line, but now we're faced with level and plumb are perpendicular, which is the sort of geometric backing of what he said earlier was as easy as the elements, right? It was as easy as 1, 2, 3, knowing that perpendicular is 2 straight lines, and plumb and level are perpendicular, as in vertical and horizontal are perpendicular.
Babe, when you ask people, do you agree? They don't have to agree. They can disagree because that's what's up, right? I mean, they don't have to agree. They can disagree.
Of course they can. Yeah.
Of course, yeah.
Now
I'm gonna unmute Bible. Yeah, that was a little unfortunate, but Bible, you got the message now, right? I mean, like, try not to rush and get. Let's try not to get angry. This is their day today, so let's just relax and listen to them and interact at their pace. You know, we'll follow their rhythm.
Everyone has their own cog dis, right? It happens in different ways for different people, all sorts of different reasons. So this one here is perpendicular when level and plumb are perpendicular. Now that happens to mean that they are 2 straight lines geometrically. We're getting to the point now where this cog dis really starts setting in. It's sort of like it's new information, but it's not new information. You've known it all along. It's like the Logos. It's been sitting there. Nobody's really made you look at it at all. So, B-Ball, would you like to comment on the fact that level and plumb are perpendicular, or vertical and horizontal are perpendicular?
Locally, yes.
Locally, but they're 2 straight lines locally.
At the point of the measurement, yeah. At the instrument, yeah. 90 degrees from vertical is your local level at that point.
Okay. So you're willing to agree that perpendicular, 2 straight lines, level and plumb are also perpendicular?
At the instrument, yes.
Okay. So we can move on then, can we? We're in total agreement.
Yep, that's good. Hey, we've been like half an hour, babe. I told you like earlier, if it's cool to every half an hour we take if there's any super chats, so to read them and so we can jump. We don't get too many at the end.
Okay, off you go. Yeah, it's a good time to take a break.
Yeah. So first of all, thank you everybody for checking in. Let me see how many people on YouTube. We got 99 people on YouTube. Hails to the 31 likes and 4 dislikes. We can do a lot better than that. So please, everybody, engage on the discussion by clicking the like or dislike. Thank you all for watching. And I got 2 super chats. The first one is by C4 with $2. Jeremy is the worst flat earther on the panel. Whoop, whoop. Jeremy, what's up?
That's not even, that's not true, C4. C4 follows me everywhere I go. He loves me.
Thank you. LB thinks stuff and more. Big $10 super chat. Thank you, LB. Appreciate that. 300 BC Euclid, a pretty smart dude like his contemporaries, teaches shapes. Non-Euclidean is how we get to space, needing hyperbolic exit of the Earth due to its round shape. FE, repeat, grade 10. Wow.
Perhaps he can come and give you
another big one. Yeah, let me jump in before we proceed, because I just threw that super chat in the daily boom so you can read it. Another big one, super chat. Look at that. It's a big $9.99 by Ben Delight. Thank you very much, Ben. Bev, using Euclidean geometry, calculate how far you must be from the sun perpendicular line of sight to the Earth in order for your line of sight to the sun to be 0 degrees above the horizon. I butchered that. I did commas where they didn't belong. So using Euclidean geometry, calculate how far you must be from the sun's perpendicular line of sight to Earth in order for your line of sight to the sun to be 0 degrees above the horizon. There you go. We got it.
You can't do trigonometry or anything to do any sort of calculation like that with an angle, especially an angle of 0 degrees, which isn't really an angle, is it? So, no, that was it. Let's try again.
Thank you very much, guys. Yeah, thank you for the super chat. Now, if we get any now, I'm gonna save them for within the next half an hour. We'll read some more if we get any comments. And you can tag me. I'll choose if the question or comment is funny or good. I'll copy and I'll read it in half an hour. So carry on, man. Floor is yours.
Sweet. Okay. Well, now we've established that level and plumb, horizontal and vertical, are 2 straight lines. They are perpendicular. We go on to the next bit. Watch out. This is the trigger one. A water level is a tool. A water level is any device utilizing the surface of liquid water to establish a horizontal plane of reference. The water level is lower tech than the more modern levels, but it can be more accurate over long distances and works without a sight line, such as around corners. And for anyone that doesn't know, if we get to the board in a bit, I'll show you what a water level is, but it has 2 ends of it with the water level at each end. So just imagine those as the 2 points at the end of a straight line, a horizontal line. They would be straight from one point to the other of the water level at one end to the other. This is why I asked for Larry to be here, because this is a tool, like it's a level, a surveying tool that does establish a level. Now, we did say a level earlier was horizontal, perpendicular to plumb. This is a water level that has 2 points, one at each end. Would you agree?
Mojok Man, have you done surveying? I'm not sure. I don't know. You do other type of work, but not surveying, right? Just trying to get somebody that got a little experience with surveying.
Nah, no real surveying. I touched the Adelaide, but that's about it.
Cool. Yeah, no harsh, man.
So, has anyone got a problem with this? I mean, we can go over the water level in a bit, but you can understand that if you fill a tube up with water, then the water level on one end will be the same as the level on the other end, because the water makes a equilibrium to each other, right?
So
yeah, the water level is in equilibrium with the forces acting on him. Sure.
So why would a water level be used? Why would you need a water level in, say, building or something like that?
Because you'd want to know where the line of the water would come to make sure it's neither higher nor lower on the other end, right? It's a horizontal. They want to make sure there is no tilt, or they want to have something some way to establish that tilt.
Mobius, you got a little bit of a hot mic, Mobius. If you can mute while you're not speaking, that'd be cool.
So again, would it be fair to say that the water level tool would be used for accuracy and precision to get as much of a horizontal? So we got George with a hot mic there too, conveniently.
Yeah, George, mute, please.
Sorry about that.
Yeah, so would it be fair to say that it's the water level tool is used for precision and accuracy in establishing the horizontal in the first place?
Absolutely. I would say it's the most accurate of all of the tools, especially over a distance, like we just said earlier. If Larry's here or whatever, anybody knows anything about any of these tools, auto levels and whatnot, they have a maximum distance that you can effectively sight and use. There was some guy from Maine. He said he only liked to go 30 meters, like 100 feet, with his line of sight, but he must have a like a 20 times scope auto level or something. So when you get the 32 times scope, you can effectively, I mean, we've tested it, you can effectively see to a millimeter at 50 meters. You are accurate at 50 meters. Go above that, it gets a bit iffy. I mean, you could probably guess to within 2 or 3 millimeters. You might even guess the millimeter, but it would be a guess within 2 or 3 millimeters, you know. But with a water level, you could have a 100 meter water level, and you would know that each end of that water level was level. The sight wouldn't come into it. It's just 2 points, one at each end of a water level.
These instruments can only be guaranteed up to a certain distance before they go out of accuracy. Seems like some of these theodolites and stuff are being used way beyond their specification, leading to really weird results and fake Earth curve or whatever.
I don't know what sort of results, because you wouldn't effectively use... I mean, if you were doing surveying and you were bothered about elevation, then you would have an auto level. You wouldn't try and attempt to do it with a theodolite. You would have an auto level, and you would stick to these close distances to keep the accuracy. You definitely wouldn't do it over large distances, anything above that, or you shouldn't do anything above that.
You'd establish a level but only go a short distance. You said like 30 meters or something like that?
That's what a guy from Maine said. Yeah, I personally would go 50 meters with an auto level, but I've got a water level of 100 meters, so my water level's better. More accurate.
And just for one more bit of clarity, like, so why use water and not something like jelly or custard? Like, why water?
Well, it's any sort of liquid, but what they do is they find their own level. They find their own equilibrium. It's an even pressure state across the surface of liquids that is perpendicular to vertical. I mean, horizontal and vertical. They're the two reference frames that we use.
Otherwise, it might get gunked up in the level. You might have a fake level where the firm pudding is, stuck at one level on one part of the tube and, higher at the other or whatever. Possibly.
Why would
flows
that happen?
Water.
I think Merrill's onto something there. You can probably pick up a lot more accuracy jelly level.
I don't know about that. It'd be too thick,
Yeah.
too treacly.
Okay. Can we carry on now? Are we going to get an agreement? Can I have a water level is a tool for establishing a horizontal plane of reference, because there are 2 points, one at each end, and as we all know, geometrically, we went over it earlier, that is a straight line in between those 2 points. Can we agree on that? That line would be horizontal.
No.
No, I'm afraid we have to disagree.
Would it be a straight line at least?
Yeah, a straight line, sure, but calling that horizontal, that's where we run into a problem with the definitions, because it's horizontal. Horizontal is very local, and at 100 meters, yeah, you're not dealing with it's close enough. But when you're going to push it out even farther, right? Yes, the water level will maintain that constant elevation, and you're looking through from one end to the other. With a very carefully adjusted auto level, your crosshair will be a little bit above it.
Okay, so but we can agree that the water would even out, and there is a straight line between one end of the level of the water to the other end of the level of the water. We call that a straight line. And I mean, when you buy a water level, it is a tool for establishing a horizontal, right? I mean, that's basically what we're getting to at the minute. We went over the fact that a level is horizontal. Now,
at the level, yes, it is.
Okay, so can we agree that a water level is a tool for establishing a horizontal?
No, it's for a tool for establishing a constant elevation.
Okay, so but we will agree that they are both, the two ends are at a even altitude, and we can draw a straight line from one end to the other. That's all I'm bothered about, and that straight line would be horizontal.
It would be, yes, it would. It would be horizontal at the midpoint, not at either end.
Well, it's a horizontal line, so all of it would be horizontal, not just the middle bit. All of it, the same line.
No, that's not what.
Wow, George, come on, please, George.
Easy. One second, George. Easy.
Yes.
Cog this, George. Remember, did you miss the beginning bit, George? Should we go over that with you?
I've heard you say this 100 times.
Did you hear the cog diss at the beginning bit, George?
You don't understand that on a curved Earth, there's a horizontal
It's your call, Bev. It's your call.
at the point of tangent.
Okay, but it's horizontal.
Can you want to talk to him or not?
No, I don't want to talk to George. You'll never get through this presentation if you let cognitive dissonance fools jump in like that. I mean, we can go into a question and answer bit at the end, but I promise you we'll never get through it if you want George to keep jumping in every time he's cog diss.
I agree. Yep, I agree.
So the water level is a horizontal. That line in between both ends would be level. That would be called a tool for establishing a horizontal. Right now, thought that one was bad. That was tough enough to get over. This is the big one. All horizontals are parallel to the plane of the horizon. As in, every horizontal that you hold is a obviously it's a horizontal plane, and that plane would be parallel to the plane of the horizon. Now, most of you trust maths. Everybody so it seems to trust maths, and if you look up the mathematical definition for horizontal, because horizontal is like a real life term, horizontal and vertical are reality words, and a horizontal is a reality word for a level, and the mathematical term of that will tell you that horizontal is parallel to the plane of the horizon in just about every mathematical definition you can find. So this is a basic fact, and it's also a proposition within Euclidean geometry that straight lines which are parallel to the same straight line are parallel to each other. So a horizontal being parallel to the plane of the horizon means that the horizontals must also be parallel to each other mathematically or geometrically. It's just a basic fact, and this is the end of the 7 of the opening fundamentals from first principles, just for reality, for the measurements and the way we conduct the geometry of reality, of what we are terming right line geometry, but it's just the geometry of Euclidean 3 space reality. Would anyone want to offer up? I know there's loads of people this playing in your mind now. How do you go against a proposition from Euclidean geometry that is a fundamental basic fact of logic? How can horizontals intersect with each other when they're parallel to the plane of the horizon?
Well, the proposition is stated in a way that allows you to discover the truth of the claim if it's, worth a damn. You can't have curved lines unless you have a straight line against which to compare the curvature. If you simply state curvature without, comparing it to a straight standard, that's, meaningless propositionally, logically, or whatever.
Mm-hmm. There's no curved lines in that, though, is there? Horizontals parallel to the plane of the horizon.
The term horizon plane, that's new to me. I didn't know the horizon is a plane.
Go, just type it in. Do a Google search now. Try Googling horizontal mathematics or horizontal maths and find any definition. It'll normally be what's it? It's not even high school. What do you call it? Grade like year 7 or something like that, I think.
Middle school.
One of the fundamentals, yeah. Horizontals are parallel to the plane of the horizon. So, I mean, look it up for yourself. We'll go away. But again, it says the plane of the horizon. So that's like, again, a plane is 2-dimensional. It's where we started this off with Bearded Devil as having a 2-dimensional surface. Well, a 2-dimensional surface is a plane, and if horizontals are parallel to the plane of the horizon, then horizontals are definitely straight lines. Absolutely. There's no curvature to a horizontal. So how could that be parallel to... it's got to be a plane 2D surface, right?
Okay, so just out of curiosity, if you have a 2-dimensional surface of a 3-dimensional object, of any 3-dimensional object, and you have a line parallel to that surface, is that surface always flat?
If a horizontal is parallel to it, then the surface would definitely be a two-dimensional surface, wouldn't it? Because horizontal is a flat, planar surface. So in order for it to be parallel to it, it must also be a flat, planar surface. I mean, it's just basic logic, basic geometry, basic mathematics.
Yeah, I just went over some basic stuff, and you clearly didn't. It didn't register.
Well, we can anyone here can reflect that back to you. Where do any of those horizontal lines start to deviate?
I just said that they were parallel to the surface.
No, but let's stay with what's happening here.
There's no deviation if they're.
You're deviating away from the horizontal
No.
and becoming irrational right now.
No, the claim was that if it's parallel to the surface, it's a horizontal, correct?
Okay, can I just go over this bottom bit here? I mean, because this might be it says
I'm good with that. Yeah.
How would you react if you were told that you'd probably want to change one or more of the above statements once reminded of a model you've never been taught anything about and only ever imagined as real? Right? It's not a trick. What we've just gone through is not a trick. But it does expose the trick that's already been planted into your brains, right? So you're acting now that you want to change something that we've just gone through there. And that was literally just talking about vertical and horizontal, two frames of reference that we all know and use as being straight lines. Now, you did have a problem with a water level, but nobody had a problem with an actual level being horizontal and perpendicular to a vertical, a plumb bob. It was only the water level. Then, when you're told that horizontals are parallel to the plane of the horizon, for some reason, I can't imagine what, you're trying to disagree with it. I mean, what's up with the fact that horizontals are parallel to the plane of the horizon?
Okay, Bev.
Yeah.
If you take a spirit level and level it, and it looks to you like it's parallel to the horizon, move to its side, and it intersects with the horizon. How did that happen if they are parallel?
Did you realign it back with the horizon?
I'm not realigning. No.
Okay.
I'm not realigning it.
Okay, well, can I give you a quick example before we move on? That you're on a boat. There's nothing anywhere. The horizon's above you, all the way around you, 360 degrees. But we're going to use a triangle, 3 points. We're just going to place one, boom, bang it down. We're going to turn some degrees. How many? 120, a third of the way around. Put another point there. Another 120, put another point down. Right, then we join those points up. We make a triangle, right, with 3 coplanar points. They're all on the horizon, and you're at the center of it, right? They're all on a plane, and they are all horizontal, making you also on that horizontal plane. Would you agree?
Bev, you just said the horizon is all around.
Shaik, hold that thought, Shaik. I don't want to have this issue in the daily boom. So anamorphic mine and crit, you are risking yourself to being blocked for the day because you're spamming the chat. I don't need no spamming today. So crit and anamorphic, stop posting the same comments, please. Please, I'm begging you. I don't want to block you, but don't do it anymore. Thank you.
Hey, Jose, when you're ready, please tell me when I can say something.
No, George, this is Bev. Bev room, Bev floor, Bev presentation, bro. And you heard me flushing the toilet, yes.
Yeah, but other
this is
people.
George. This is Bev room. It's Bev rules. When he's ready for you to talk, he will let us know. Thank you. You can mute for now.
Okay.
Okay, I don't know. We were just trying to establish that the horizontal, those 3 points on the horizon, would make a plane, and that plane would be horizontal, would be a horizontal plane on the equal with the plane of the horizon.
Bev, you said the horizon is all around you.
I said imagine you're on a boat in the middle of nowhere with the horizon all around you. Put 3 points on it.
So how can a straight line be all around you?
That's an interesting one, isn't it? That's the Dornagon. Yep. It is a straight line, though, isn't it? Every time you look out and the horizon is a straight line.
No, because it's all around you, like you said.
Well, yeah.
Could you go back to the graphic with the water level?
That one?
In that graphic there, the blue water level.
Yep.
You have 3 points. You have each end and the middle.
Yep.
And you're saying that is a simple straight line.
Yes. Yeah, we'll get onto that in a bit if you want to. We're going to jump on the board in a minute. You ready for it? You want to come? We'll go there, right?
Well,
let me just put this camera on. I'm ready to go.
The line established by the 2 endpoints parallel to horizontal at the midpoint, but are only about 800 microns different. So since that would be hard to measure and impractical to measure, and in practical terms, you're using a water level in a construction environment because you're trying to, establish a constant elevation on the other side of a wall or around a corner. Yeah, but it's just so small that you're nearly the same, and you're going with nearly the same as being exactly the same. And it's only, like I said, 800 microns different.
Right, can you see the board? The Jose, let me get the mic.
Let me see YouTube live. I do not. You turn your camera on. The video chat isn't available for more than 25 users. Damn, and we got.
Oh wait a minute. I'll have to switch it. Oh, I can't switch virtual camera.
No, we're gonna need volunteers. So hold on. Yeah, but hold on. I'm gonna disconnect a few people that is deafened because Ross and the Rumpus was here doing nothing. They were deafened. I need 3 volunteers a few volunteers to drop while Bev turns on his camera. And then you guys can rejoin.
What, are you turning your... You want us to turn the camera on? We can stop the screen then for a bit.
That's right. All right, we got it now. Okay, yep. Let me share you for YouTube.
I don't know whether people will be able to come in anymore.
Yeah, let me share you on YouTube. Hold on 1 second.
Yeah, make sure the sound's good as well.
Sounds good, Bev.
You're up. Hell yeah.
I got you loud and clear, Bev.
Yeah, you're up.
Right. See this? This is This is a model, one of your guys' models. We call this one the drop model. Now, geometric drop model. So you've got a start point, and this is where a water level drops. I think this is the most ridiculous of all of the models. So we've got a water level like here. Oh, here we go. Just for anybody that doesn't know what a water level is. Right, it's
I want to thank you very much to some of the guys that dropped from the call so you can have your camera on. I really appreciate that. Hold on was one of them, and the other guys, thank you.
Cheers, guys.
Bye, bro.
Right, so this is just a tube, and right, the tube and the water, it equalizes out. See that? So you move it and the water just equalizes. Now that happens, you can have this one here for far away, right? These two will always equal out to be equal, right? Always. The water does that of its own accord. The tube, I say, has no limit for length, and the water will always equalize. So that's what we're basing this test on, is just the water in these tubes in reality, and we're going to be using these to perform most of our tests to form a level, because although we have auto levels, as I say, I think these are more accurate over larger distances. You could be much more accurate. And as a matter of interest, you see that both of the levels at each end there, you see this, the water level is effective and it always works. Even when you can put the water level up there and the water level still acts, but there is a maximum distance you can move that up there. I'll leave that for people to work out. Pretty interesting when you work that out, to keep the water level functioning as a level, establishing a horizontal. There is a maximum distance it can go up there. Think of a siphoning one water from the other, from one end. So we're going to use a water level, but this is on one of the models. We'll start with the drop model. That somebody once said that the water level drops at a distance of, anyone like to hazard a guess? What distance? So what we do is we'll put a level, because we have a horizontal. Set the horizontal there with the water level. So we've got a water level, so we can actually have a water level there, fill it up at this end. Now, if we say this here is 1 mile, right, and then this is the horizontal, there is a claimed drop from the horizontal of a water level on a model of, well, we could say, if we say this is a horizontal scale this way for 1 mile, that's about 30 inches, right? 30 inches to 1 mile this direction. If we could say this one is an actual realistic drop, so we could say that on the model there is 8 inches. It's 8 inches from there would be to there. So this is an actual drop of the water level. So this drop here is 8 inches. So that's a real scale, 1-to-1 reality scale. So that's a claimed drop. Is that what we were talking about earlier? I think George, was it George or somebody else? What do you think? I mean, this is the drop from horizontal over distance.
Yeah, that's true.
So that
true and observed, frequently measured, absolute reality observation. Granted, that sketch and I are completely Complete agreement.
Okay, well, I see. I think this is one of the more ridiculous. That to say that there's a drop from horizontal over distance. I mean, that I thought as a surveyor, isn't this drop from horizontal? Wouldn't this be called an elevation change?
Oh, the tops of the water columns are the constant elevation.
But there's a drop from horizontal.
Only from the instrument location at the far left.
The horizontal is different from the right.
This horizontal isn't horizontal.
It's horizontal on the left end.
Hold on, George.
Who's that shouting?
It is horizontal at the instrument, and only at the instrument.
But horizontal is a straight line, and a straight line has 2 points. You said that earlier at the beginning.
Yeah, and I did agree that, at that instrument, perpendicular to vertical, the local horizontal, and a mile away is no longer local. The tops of the water column are a constant elevation. If that's
maybe the way to say this, horizontal is only from the perspective of where it's established.
Hey, George, your microphone is terrible. So even if you contribute, you got to improve your audio. But please only spoke. Let that control for now. Let him. It's his show.
Right. So this is the drop model. Now, I say, and I think most people would, apart from you two, who I think are you two are the surveyors, but I mean, what does everybody else think? I mean, I would say a drop of horizontal would cause this would be water flowing. This would be a river. If the water were to move a mile and drop 8 inches, that would be a flowing water.
Well, it's only a drop from the tangent of level at the instrument. It is a constant elevation, which, as you aptly pointed out, is an equilibrium, an equipotential, an equilibrium equipotential is a constant elevation. Yeah, it does drop from the local tangent at the instrument, not anywhere else, because, and this has been measured so many thousands of times. I can't ignore that 8 inches. Otherwise, I don't get a constant elevation.
Okay, so I can't see how you would have. Again, you're not saying that horizontals intersect, are you? I mean, how could you have a drop of 8 inches over a mile? Isn't that would be a grade, right? This horizontal, this distance, and then this is here. If any distance from the horizontal would form a triangle. That triangle is a measurable longer distance than the horizontal.
Okay, now for that mile, we are going to lay out a road that has to have no slope. So you will take your auto level and you will measure elevations all along the way. You probably won't use a water level at a full mile. You will measure elevations along the way, and you'll be moving your instrument every 200 to 300 feet. And you'll be making 10 measurements or 20 measurements between those 2 points at that mile by moving your instrument the whole time. So if you have 10 setups, you will have 10 different little level tangents, and you will get a very accurate constant elevation. If you shoot from one end at a mile, then yes, you have to account for the curvature. And all electronic instruments, by the way, have that incorporated built in. So, and I don't see any surveyors turning that off. And my analog equipment does not have that.
Turning what off, Joe? Turning what off?
The electronic instruments in the current generation already calculation.
Larry, your microphone went to crap, man. You might be in a bad spot, but your mic is gone, man.
Yeah, that was interesting, that newfangled technology. We're just talking about water levels, and this is ridiculous. There's no way this drops Not at all. This establishes an even altitude. This water level, this tool establishes a horizontal. There's no drop from horizontal, right? I mean, there's no way you can measure that drop, is there? Because that would be a flow of water, a measured drop from the horizontal. And the horizontal, as we just said earlier, was established by a tool called a level. This is model 1.
I thought you were going to propose a test.
I am, yeah. I'm just trying to get over the ridiculousness of how this is the reason you guys have not been able to do anything. You can't make measurements because your people are telling you that, I mean, who are the most trusted people here? You've got George and Larry, both of them, saying that a drop of 8 inches over 1 mile is what water does, but it doesn't. Everyone knows it doesn't drop.
Bev,
it's called flowing water.
Bev, at your second water level, the one on the right, draw a line perpendicular to the ball.
What?
On your drawing there.
Yeah.
Make a line perpendicular to the ball.
What ball?
The curved line that you have there.
It's just a curve. It's not a ball.
Okay. Put a line perpendicular to that curve.
You can't. There's not such thing as a perpendicular to a curve. Did we not just do that earlier? Perpendicular is 2 straight lines.
Draw a line from the right-hand water column to the center of your arc, a radial.
For what reason? You want to do Page's proof and realise how ridiculous it is. You want to call a line that comes off here that cuts this horizontal here, like that, not perpendicular. You want to call this perpendicular, do you?
That's what the assertion is.
Yeah, it's ridiculous. Your assertion is ridiculous. I'm going to give you the hump. I'm going to give you the hump because the Kozlowski nutsack drop is one of the most ridiculous ideas ever proposed by the globe model proponents.
Okay, wait. May I? Is my mic better now?
Yeah, go on. Go on.
Okay, from that hash mark on your level line that's on your far right, where you're showing it's ridiculously not perpendicular.
Mm-hmm.
In reality, that's 89 degrees and 59 minutes. So it's only 1 arc minute off of perpendicular.
It's not perpendicular then, right? You're saying perpendiculars aren't perpendicular. Horizontals and vertical aren't perpendicular. Ridiculous, Larry. Ridiculous.
At 1 mile away, it's only 1 arc minute off of perpendicular.
What were you saying earlier about the modern electronic equipment?
They incorporate that 8-inch drop from the local tangent, and no surveyor turns that off, and that's ubiquitous in all instrumentation, and many surveyors laying out foundations at 2,000 or 3,000 feet or road grade at 2,000 feet, those small increments are applied when reporting elevation so that they don't make a mistake and make a puddle. So you have to also argue with the manufacturer of all current modern equipment that have curvature built in and that no surveyor turns off.
There is a switch then. You just leave it switched on.
Absolutely, there's a switch, and you'll see. Will report an inaccurate. It'll report a height difference that will not be an elevation difference.
Right? Is it? Do you switch the curvature on? So like, is curvature in the on position, or do you turn the curvature off? Right? Do you have which is your positive, which is on and off?
Right, it is right. There are menu options, and when you hit factory reset default, it's always on, and you may turn it off at your own peril, and nobody does. And anytime you go to a factory reset, on is the normal, because when using a theodolite, and observing something which may be at a different elevation at some distance off, say, mile or, yeah, it does report that elevation after applying the 3,960-mile radius of planet Earth, of which we live.
Okay, well, I've just got an auto level, Larry, and mine doesn't have a switch on it. So mine won't have it. Will that have it already set in the on position? Like an auto always on? Or is that an auto always off?
Wait, you have an auto level, so it has no electronic means whatsoever.
Yeah.
So you don't have a menu of options. Much like the example FE Core pulled up.
Yeah, that's what I was asking, Joe. Is it in the on position or is it in the off position? Because some guy from Maine said something about applying curvature corrections. So if it was already on, you wouldn't need to do that. So I'm taking it, my auto level has it in the off position.
Oh, no, you don't know your instrument very well. Your instrument doesn't even have that option. Your instrument is an analog instrument, not an electronic instrument. Analog equipment, yes, it is up to the operator to control and maintain these things independent of the instrument. I said modern electronic instruments, of which your auto level is not.
Okay. Right, so it's still good at finding a level, though, right? Here we go.
Sure. You know what you're doing. Yeah, absolutely.
But no on and no off. Right?
Yeah.
Okay,
yeah, because it's an analog instrument. Right? If you were to lay out a constant elevation over the course of a mile, you would have to pick your gun up and move it every couple of 100 feet. And then you would be absolutely perfect.
Okay.
And if you set
next model.
If you sat at one end and looked across, you would find your crosshairs are above where you think, and that is because the 8 miles squared is an absolute given, and it's incontrovertible.
Excuse me for interrupting. I think the pilots have to turn off the converter permanently. Just forget the converter. Excuse me for the interrupting.
No problem. Right, so here we go.
Turn off the converter.
We're now...
Sorry.
Babe, maybe you want to finish maybe a quick point because it's time for a few super chats, but you can maybe go ahead and wrap up
you want to do some super chats because we're on a model switch here. You do your super chats.
Oh, good. Yep. Perfect segue. Yep, perfect. All right. Again, shameless plug. Hit the like or dislike if you haven't done so. 100 plus people watching. Thank you everybody for being here. Thank you for all the panelists for being civil over here and following the rules. Everybody in YouTube chat, troll responsibly. No personal attacks, no swearing. Okay, I got John Hansen with 100 Donkey Kongs. Thank you, John Hansen, for the super chat. Great Belt Bridge in Denmark Tower. Plum, not parallel. Flat Earth is stupid. Boom, he said. A Great Belt Bridge in Denmark. Towers plumb, not parallel. Flat Earth, stupid. Boom. Thank you, John Hansen. I got a $4.99 super chat by Rocky Alive. Rocky Alive say, free the Nuggets. All Nuggets lives matter. Nuggets lives matter. So shout out to the Nuggets. Thank you, Rakia. WS says, is Euclid... Perhaps Bev could explain why Euclid says the horizon is a circle. Euclid wrote, and I quote, the horizon is a circle for if a sphere be cut by a plane, the section is a circle. Do you think about that?
Well, not in the elements. We're talking about geometry here. I mean, he wrote some other books, did he? Or is that just the one that they found that was wrote in 1969 or something? I don't know. As far as I know, that was as far as we could track that particular book that he keeps going on about. I mean, he's been saying that for ages. Can I say, WS, anytime you would like, we're open to have a chat for geometry or anything like that. Any of this talk about Euclid.
Bev?
Yeah?
Bev?
Yep.
Did they say there's a switch to turn off the Earth's curvature in their theodolite?
I think that's what George says. Just the electronic ones.
So that is fantastic. We can do a test with it on and then turn it off.
Only with theodolites. We do elevation. We don't use theodolites. We use the auto levels. They're more accurate.
Could this just be the way that they convince them that there's curvature by putting a switch on there that does absolutely nothing? Like you said, nobody ever uses it. So let's do a test with it on, and let's do a test with it off. See if it doesn't pick up the 80 drop.
Just show us the switch and the manual. That'd be handy.
And I didn't.
Hold that thought, Larry. Can we get through these few more super chats? Few more comments I got here.
What?
Let's push through these comment super chats over here. I got 3 more comments to read. Hold on says, it's time that we ask for questions like, we like to see if Bev has a hypothesis how your water level should look like if the Earth is a globe. That'll be interesting to listen to, but he typed that one before you actually brought this whiteboard and you just went through it. So that's a little. Doofus Manfred says for $5. Thank you, Doofus. Bev, because TP won't answer a basic geometry question. What shape is defined by a fixed distance around a center point in all directions in 2D?
Wow. I mean, how much was that for, Jeff? I'd say...
That was a $5.
Yeah. Wow. You just for hear me say it's a circle. Yeah. A circle can be described from any center and any distance from that center. That does sound like what you were saying, some sort of a circle.
And the last comment I got here is by Beard the Devil. That's the super chat I got for now. He's away from the microphone. Can I ask Bev, what happens if you sight a water level to the flat Earth horizon? Is the water level still level?
What happens if you sight a water level? If you do that, we laugh at you. It's a running joke. We have a new range of dark shark water sites. Perhaps you've heard of them. Ruhif started it. It's obviously a joke. Why would you need to sight the water level? It's there. You don't need to sight it. It doesn't matter what happens from one end while you're looking at it from the other end. You could just go here and look at it. That's what we're going to be going over. Is the sort of paradox of the model, the 2 different models. Are you ready now, Jose? You done?
We are ready. People is excited in the chat. A lot of feedback is coming that they need to see your setup now and explain it.
Okay, so well, we're just going
go
through
ahead,
this.
take the floor, bro.
Yeah. Right, so this is the second model for the globe. So I've found this is called the hump model. Now, there's a couple of problems with this. The first one, the problem that you had was the drop in horizontal is a change in elevation. It's obviously a drop. This one is the one that allows you to imagine that they're still level. They can equalize out and be the same, but there's an imagined hump in the middle. Now, we've got a water level, and there's a line that goes from one side to the other, right? I'll draw that. Okay, your horizontal. Oh, that's well.
Hey, while you drew that line, Brad Wagner, this one just came late, but it was like when I was wrapping up the super chat. Brad Wagner says, thank you for the $5, Brad. Tell Bev, thanks for kicking me off the EMA UK server. I was just trying to hook you up, and Jose, he said. Thank you, Brad.
Okay. Well, the story about that is that it's Emma's server, and yeah, Emma. Somebody was going round last night saying a load of weird things about Emma, and Emma decided just to shut the server down. So you can, I think you can specifically thank Crit for that. So Emma, if anybody's wondering where Emma is, she left all of the debate servers last night because she just can't be dealing with drama. So yeah.
All right, take the floor, brother. I don't interrupt anymore.
So we've got a water level here, and it stays level from one side to the other across it. Across here, and there's going to be a line. We'll call it the horizontal line. Or the level line from one side to the other. Right. So that's the level line of the water, the level of the water from one side to the other. Now there's if we tap one in the middle, a water level, we'd have to do it like that, wouldn't we? Then when we fill it up with water, I would say the water level would be on this line, the same line, but obviously other people have another imagination because there's a curvature to this level, right? What is perceived as a level. So first of all, we going off what we've been dealing with, the water level. Can anybody have an idea of where we want to fill this water up? If we were to pour water in here and tap this in with another level there and fill the water up, where would anyone imagine that the water would go to on this?
It would go to the ark.
Up here?
Correct.
Okay, so should I fill this up with the water up there?
Please do.
Okay, now...
Yes, please. For argument, yes.
When we... this is
now,
Larry's taking the...
okay, let me finish now.
The helm, okay.
You've got your long horizontal line.
This one?
And, yes.
Okay.
And the distance for the arc.
Yeah.
Okay. And this water level, you say you use at 100 meters. So
this water level? Can we flip it up a bit and go scale it up a little bit? Can we say 23.7 miles?
No.
Shout out here.
You said
and we'll have this as one level point, and we'll have this as another level point, and then we'll also have this in the middle.
You said that you used your water level at 100 meters. So let's do that for right now, and then we can scale it up later. So you say you use it at 100 meters. That's how big you used your water level, at 100 meters.
Well, yeah, but that's not the biggest water level. The biggest water level we know about that has been measured is this one here. 23.7 miles. Right? Now, there is a level point at one end and a level point at the other end. And then there is, claimed, another level point in the middle that isn't on a hump or something. It's definitely on a level. And then we've got 3 coplanar points. Bam! So what's this distance here, do you reckon? Because this is definitely because that other one, that first model, was drop from horizontal, right? There was an arrow there. Now this one is a horizontal, and now you've gone up from horizontal, haven't we? Do you know this? Do you know this distance here?
Yeah, the 23-mile line is a chord.
Yep.
And it'll be about 93.5 feet below the arc.
Yeah, I do meters. I don't know why, but we'll have miles and meters as well. How about that? Do you know what it is in meters? I do.
28.5.
28.46, isn't it?
I got 5.3.
Meters.
What? Yeah.
Oh, you got 5.3.
Yeah, millimeters different. Round up error. We could ignore.
So that is definitely an up from the level to the level of 20 odd meters.
No, because that's a constant elevation at all 3 points.
But it's from this. You called that a horizontal. Is that called a horizontal?
You called it horizontal.
No, you
I
did.
called it I called it a that is parallel to the horizontal at the middle.
It's parallel. So it is a horizontal then. It's parallel to a horizontal.
Parallel to a horizontal at the middle.
So it's already it's a horizontal then. All horizontals are parallel. So if it's parallel to a horizontal, then it's horizontal. We went over that logic a bit earlier. Proposition 30.
Yeah, that was said all horizontals are parallel. Only locally.
Local there and there, both parallel.
Locally, there at the middle, they are parallel.
Okay, but okay.
And in that example, they're parallel and separated.
Yeah, but it's this would be a body of water, and this would be a midpoint above the level from either end, right?
All 3 points are the same elevation. Yeah, okay.
But this is above these two, right?
Above that chord.
Yes, above.
At chord. Call it a chord.
Yeah, but it is a level point from this level to this level, isn't it?
It's a chord. It's a chord.
Yeah, you want to call... Okay, so what a water level to you is from one end to the other end, we call that a chord, do we? Not a level. It's a water chord machine. This here, from here to here, is a water level in my place, but you want to call it a chord. Do you?
When you get up to in the multi-mile range, yes, sir.
Okay. But not locally.
When you're working at 100 meters, that height is so small that you could hardly detect it. So yeah, it matters. Size matters.
Okay. Well, that's where we're going to go to next, right? Because I mean, this definitely matters. Do you know the cavitation point of water? As a matter of fact, you know, I said earlier, we get a water level and we can lift this up, right? And there's a maximum point that this tube here can go up above the level here of this line, just that will stop this water level from working. It will stop it from functioning. Do you know what that is?
No, you're wrong.
It's the water column of 1 atmosphere.
Okay. And is that above or below that?
Above or below which?
The water column of what you call it. Is this above or below that water column that you talk about? It would be like a vertical column, right?
Yeah.
Yeah. Above the level of the water, like established, like we said here. This bit would go up. Right, I don't want to get bogged down on this. We can go into this at some other point. No doubt we will have to go into it. I don't want to get too advanced.
Move on, Ben, because you have 3 points. The tops of those water
with a hump in the middle.
The same elevation as the left and right point.
Okay, so but that's what, right? Because this is obviously measured, right? This is a measured number. This is the hump. Easily above the line from here to here is up. Yeah?
Yeah. Okay.
Okay. So that so there's an established. There's a part here that is measurable, and it would show a curve, right? It's not a straight. I mean, this is definitely a straight line here, and this is a deviance from this straight line.
Yep.
Okie dokie. Right. So that's the two models done from the from your globe, right? Either one of them is a drop that it goes and it constantly drops away. That's a bit silly because water doesn't do that. And the other one is a hump, a rise from horizontal, right? A rise from the chord, sorry. They're both horizontal. Now, thanks to some nifty calculations, I'm not so sure anybody's actually done any measurements or anything, but we have. Can I give you these measurements? I don't know whether we can put them. Which channel are you in? Daily Boom.
Whee!
Right. Now, in the Daily Boom there, there you go. Can you see that? We've got the Baller local curve calculations. Have you got that on your screen, Jose?
Yeah, it's up. Yes, it's up.
Okay, now if you look at that, you'll notice that it is 16 individual 100 metre unsighted water levels. So this is, if you imagine from one end to the other, these are separate 100 metre water levels, but they're not even connected. You know, they're just individually. So where one end of the water level from one end, like a U shape, where one end finishes at 100 metres, another water level picks up, and you measure the water level, and that goes another 100 metres. Are you with it? I'll draw it in a minute, but just to get you all in the mood, I gave everybody the make sure you could do your calculations with this last night. That these numbers here, I take it everybody's been over them, and they are good numbers. They've been checked by quite a few of the top globe calculators who do this sort of stuff. Now, the purpose of the test is to find that hump, right? That hump that was measurable in the hump model, because obviously, like we said earlier, the drop model is ridiculous. The water doesn't drop. That we call that flowing water. It's water changing in elevation, and so that cannot be measured. That would just be level water not dropping. So water not dropping can't drop. So all we can look for is the hump. Now, if anybody knows the maths of the way their model works, the drop over the 200 meters on that is 3.1 millimeters, but obviously it can't be a drop. But because the maths works like that, it does. If you double the length, that drop turns into a hump magically. The one model, the drop, turns into the other model, a hump. It's fantastic the way the geometry works for the model. But so that's where we're going with this now, right? Once you've got that in, now you would agree that with a water level, do you want to? I'll go back on the whiteboard again. Right,
I thought we were going to talk.
Go on, sorry.
I thought we were going to talk about the field experiment, the experiment you want to run.
Who said that? Sorry, who was that?
It was Larry. I thought you said you were going to discuss your field experiment that you want to do.
This is not an experiment, Larry. This is just pure geometry. In reality, using a water level. It's not
Okay,
an experiment.
Yesterday, I thought you were describing, outlining an experiment. That's what I thought you.
Okay,
yesterday.
this is a test, and we are getting around to it, right? We are getting there. Just trust us. We're gonna get there. This all of this stuff, step by step. I've shown you where we're gonna measure now. This hump that you said was measurable, right? So what we do is, this is the method. We're gonna get three sticks. Oop. Right, and we put them in the ground. We're going to space them out 100 meters. Now, like we said before, we can't go for the drop because a drop's not doable. So what we do is we get a water level. And here we go. So this is what we've got. You've got, see that? That's 100 meters scaled thing, aren't they? It's not really. It's just a tube, right? 100 meters, like this. 100 meters of tube here. Then we have an upshoot, and then another 100 meters. And then another upshoot, and another 100 meters, another 100 meters to the end. So we've got 400 meters of water tube. Now, according to the numbers that we had before, over 400 meters, 400 meters is, what's the drop? It's 12.6 millimeters. But I mean, obviously there's no drop there, but we can find the hump in the middle of 3.1 millimeters. That's what we're looking for. Now, you see the water level there and a water level here. If you were to have a pencil, how accurate do you think you could mark that level? I'd say you could milk it to the pencil. I've got a really, really fine pencil. I could do it to, well, I don't know, 0.1 of a millimetre I could do it. But I could look at that and judge it on the meniscus there and be, let's say, a millimetre accurate, right? So I could be a millimetre accurate with this when I'm marking it. So what I'm going to do is I'm going to lay these out, these tubes.
Right on, Biff. You are. It's very good prestations, and you are making it.
Okay, now each one of these, 100 meters.
It's very, very long prestation, and you are really
400 meters.
You are taking the floor.
Okay, we're going to fill it up to here on this one. We're going to call this one number 2 because it's the second one from the end. We're just going to fill the water up and we're going to mark it water level. Right? Just in reality, this is what we're going to go for first. You guys can, because this is a straight line test, right? To prove that this water level is a straight line, not a curved line. So, if we lay this water level out and all of these are on a straight line, how do we check that they are actually on a straight line? Well, you've got to use a bit of geometry and a bit of reality, right? To check that. The best way to check would be there's no shared straight line segments across, all the way across from here to here to here to here. Now we could we've already done this. You could check this yourself. You could put an auto level, one of these here, in the middle of this and check that level is level with that one. And then you could move and do all your transitions like Larry was talking about, and you could move your auto level and check that all of these are level. But we're just doing a pure geometry test here now, right? That's all we're doing. We're taking it as though these water levels are individual. Each point can be drawn as a straight line from one point to the other all the way across. I say that's what a water level does. There's no hump or anything of a water level. Water can't support itself like that. Couldn't have an equal pressure state. Right, so what we do is, once we've done that, just laid these things out and marked them on the posts, we grab hold of our water level that's out here like this, and it's here. What we do is we scoot it over here. Just move it, the whole system. Move it over this way. So it's like this.
Dude, this cat is all over me, man. Like in my keyboard, in my mouse. He doesn't leave me alone. What the hell? He shows me and he's all over me. Holy cow.
Right, so then what we do is we fill the water up on this one again, number 2 post. Because again, it's the second one from the end. Right, so we fill the water level up and we just mark it with a pencil again. To this post. To all of them. Now, once we've done that, what we effectively have here is a straight line that goes from one end to the other, with these 2 sections here being a shared straight line segment. So what you could effectively do with this to check is, if all of these are together, then this is a shared straight line, and you could move it once more again, and you would end up with again a shared straight line segment, and you could just carry on with that one section of now we've chose 400 meters because of the numbers that we showed you earlier that have been given to us, the hump numbers, the measured hump number. Well, not measured, calculated, obviously, because there's no measurement. How could you measure anything? You could, but use the other model, the hump model. So from here to here, the middle one would have to be higher on the hump model that we had. Obviously there's no drop, so the hump would have this one higher. But when you mark the water at this one, I mean, I'll leave it up to you guys. What do you think? It's just all based on the principle of shared straight line segment. I mean, it's cheap to do, uses practical geometry, using logic to know that water level doesn't drop, and obviously doesn't hump.
I'd be very excited to watch you do it.
Would you be happy that would be a geometrical proof in reality of a shared straight line segment?
I agree that would be all those points would be at a constant elevation. I do not agree that it makes some sort of continuous chord across all points. It would create a 3,960 mile arc.
So you would say that this sharing of straight line segments to you would prove a circle?
Well, yes.
Yes. That sounds an awful lot like a Dornagon.
Yes, because they'd be a constant elevation.
Okay, so is that you saying that because that's overriding this geometrical proof of a straight line with a shared straight line segment. I mean, I'm not saying this is what would happen.
The shared water column segment would return the constant elevation of the tops of the water in all cases, which at 100 meters is imperceptibly small, but if you extend it out to be a mile, yeah, then you could start to do some measurements where you have distances which, you can approach with, a ruler, 4, 5, 6, 7 inches, yeah.
Are you saying can you not measure 3.11 meters with the water level? Like, let's say, see these here, see this? This is a water level. Right, this is 100 meters of water level. Are you saying that you couldn't measure 3.1 millimeters if you had a water level that was long enough?
No, absolutely not. The water level would easily return precisions at the millimeter.
Okay, so this 3.1 millimeters would definitely be measurable then, right?
Yeah, the question is, how are you going to measure that? Like, you're going to have to measure it against a tangent from one end.
Okay. Can I just give you a quick idea, right? So from here to here has a hump like that, right? And then you've got this red one here that has a hump like that.
Nope.
What?
No,
is that not how it would work? Would there not be a hump from one end to the other in the middle, like you just said earlier?
Those two arcs have a common center point.
This one end of a water level to the other with the hump in the middle, right? One end of the water level to the other with a hump in the middle.
You drew two arcs, and those arcs have different center points. And the correct drawing would be arcs with common center point.
Yeah, but that's where the water level, the hump is in the middle of the water level. From one end to the other, hump in the middle.
And those arcs would be concentric.
How would they be if you moved one to the other?
Because they're progressing over the surface of our planet.
This shared straight line segment would just keep going on and on and on, though. With no hump shown in the middle of each section.
And that is your conceptual misunderstanding. Those arcs would be concentric with a common center point.
Okay, so have you got any comment about the shared straight line segment in these bits here?
Yeah, they'd be just fine. All those marks that you've made on there would be a constant elevation, and that constant elevation in three-dimensional Euclidean space is in fact the 3,960 mile.
We're looking at it side on. This is like an elevation view.
Yeah.
Yeah.
Okay.
And so you were happy with them being a shared straight line segment all the way along?
Well, I'm happy with that diagram representing a constant elevation, but that constant elevation is a 3,960 mile arc. So when you drew those two, that red and blue underneath it, you forgot to draw them concentric.
Well,
concentric. Now, is that supposed to be a mile?
Yeah, 400 meters. Like I showed you with the numbers, since we were given the RUHIF numbers and all of those numbers for Slice Barkane's 1,600 meter water level. These are what Slice Barkane's gonna. I mean, he was going the full 1,600. He was gonna measure 200 mil at one end drop. But we decided to do it and make it more cost effective, right? You can not measure 3.1 millimeters and show that it's a straight line, but in 400 meters. I mean, all of the equipment to do this test for yourself can be done for about 100 quid.
Okay.
I've got it.
I'm looking forward to the execution of that in the field.
Okay, so you like it then? It's a good test.
I like it because I know I am more certain how that will play out. And those arcs that you drew underneath that will be concentric.
The arcs aren't there. The arcs were to show you reducto ad absurdum. This is a straight line with a shared straight line segment at this point.
But Bev, how did you establish a straight line?
Between the shortest distance between 2 points. I mean, like how we established a straight line.
No, that's great.
Did you miss that?
I can draw a triangle with the shorter distance with straight points. How do you make sure all the posts, all the marks are on a straight line?
Because they have a shared straight line segment. We made the same marks at the end of the water levels at each point.
I can draw a triangle.
You can draw a triangle.
Relax. Relax.
Is that the best you've got, Chike?
Look,
you can draw
if I have 3 points, yes, I can draw a triangle with straight line between
this is a shared straight line segment, right?
How do you make
you can draw triangles.
He told you.
Put little legs on it.
No, he didn't.
A face or whatever.
Needs to be a single straight line.
Yeah, here.
From the last
post. It goes all the way from here, all the way to there, because these ones are shared straight line segments. Or, what we could do is, we could prove that these are parallel. Right? All horizontals are parallel, because they would be the same distance apart from each other, right?
No, I mean, how do you prove they are parallel?
I'm just saying, this is a straight line test, a geometric straight line test. Well, if anybody wants to come over and work over the principles of it, because it does get pretty, well, it doesn't get complicated, but the simplicity of the test often confuses people, because it's how a water level works in reality. You have to start to trust yourself to know that the water level establishes the level. Like, you don't control this stuff. The water does it for you. You just make marks. And like I explained at the beginning, this point, there is a straight line. Call it an imagined straight line. But, I mean, you could move one end of the water level to here, and it would be markable, right? So the imagined straight line is there because the water level establishes a horizontal plane of reference that comes all the way out, all the way back, all the way across.
No, that's what we're arguing, that water level is not a straight line.
Excuse me, I have to come in. And you're talking about straight lines. Straight lines is so big. You have to understand, what were you talking about? Straight lines? Straight lines like a light. Every light is going in straight lines. And if you are using measurement width and using straight line of light,
this isn't light.
It's the most accurate you can use.
It's your call, babe. Your call.
Yeah, this isn't light, John. This is physical water level.
Yeah. We have talked about that very a lot. So
yeah. But I mean, that's what we're doing here. We're trying to sort out a geometric test for a straight line. In reality, we call it right line geometry. This is the sort of stuff.
You're absolutely right. I just will point out in the straight lines matter. There is also straight lines of light, and every measurement of straight line of light is proven in the flutter. Just will point it out. With radar and microwaves and whatsoever. Sorry.
All right, babe. Yeah, babe. Let us know. I got just a handful of super chats. It's almost that time, so.
Yeah. Well, you can go for it now. I think that is the test, right? You guys now can discuss how valid you think that is. Now, I would offer you up that 400 meters, I could do this on my own. I've already got the equipment. I've got the poles, I've got the posts, I've got a pencil, and I've got some water. I can. This is me being able to do this is very easy at this point.
And the water tells everything. Water is the life.
John,
And the,
can I?
Water, yes.
So yeah, I'd like to be able to do this, but I'm waiting for my son. I'm waiting for the COVID lockdown to end, so we can all do it as a family and go out and do it. So yeah, we're ready to go and try this and do it.
Yeah. Hold on, Larry. Hold that thought. Let me do a handful of super chats here.
Yeah.
I only got 3 or 4 now. Right. So thank you so far. So far so good. Everybody have behaved. So let's not allow this get out of control after this quick read super chats. We got Trolling for Truth. Gave me $5. Thank you, Trolling for Truth. Can Larry explain or elaborate on how his equipment account for curvature? Does it use the 8 inches per mile square formula and or something else? Thanks. Larry? All right, we might get back to it. Let me go to the next. Is LB, Things, Stuff, and More. Thank you, Latonia, for the $5. I now represent the hump, and we are submitting a cease and rescind order for deformation of character. We will require a formal apology. Thank you very much, Latonia, hump representative. And Latonia, LB again, thank you for the next $2. Taking donations to start a FLIRF rehab. Anyone? Well, I got DKK that jumping with 50 DKK. 50 Donkey Kongs again. Thank you, John Hansen. And he say, Bev brain is the size of a Planck volume on a high. Don't have one? Or, Bev brain is the size of a Planck volume, or he don't have one. There you go. I fixed it. Thank you very much. So Bev say, and that is the test. Floor is yours, gentlemen.
Larry is not home. Larry is not. Larry is escaping.
Just caught me on mute because I was beginning to drive. All right. To answer that question, the firmware in modern electronic instruments has a full geometric calculation, not the simplified 8 inches per mile squared. However, when using typical construction grade or high grade instruments, limited to about 5,000 or 10,000 feet because of the laser range, not because of the Adelite's accuracy, but from the laser ranging. So it does go through the field calculation, but at 5 miles, it is equivalent to 8 inches mile squared. 8 inches mile squared is an approximation, yes, but under 20 miles, the difference is insignificant. So 8 inches per mile squared is often cited because in a pre-calculator world, it would calculate and you didn't make mistakes, and at only a mile or 2 or 3, you had no benefit in going through the longer trigonometry. However, in all modern softwares, of course they use the full trigonometry because it's software. But if you had a pencil and paper, yeah, 8 inches per mile squared, be done with it, and you won't make a mistake.
You're monologuing bullshit.
Is that like a measured drop from the horizontal or calculated drop from the horizontal with the optics? How does that work?
Bev, quick question for you, Bev. Are you okay with John Bernard's kind of jumping in because he will destroy the presentation?
I know, yeah. I'll leave it up to you, Jose. You know.
All right, cool. Got it. Thank you.
I just want to say that Larry was wrong there. He just was monologuing, and there was nothing nobody can take anything away from it. It's somebody in the chat, but understanding what they were saying.
Thank you very much, John. Appreciate it. You guys can move on.
Yeah. So, is that it's always confused me this switch. Because when you use surveying, at least when I did surveying, we measured a drop from horizontal. That's what elevation is. It's a change from horizontal. It's a change in the vertical measured from a level. It's a tool that establishes a horizontal. I mean, that's what an auto level does, isn't it?
Yeah, and you would be measuring that at those 100 or 200 feet or 200, 300 or something, in which the curvature is so minuscule that it's not a big deal, and you pick the gun up and you move ahead, and you do it again, and then you pick the gun up and move ahead. So you're not accumulating curvatures. Theodolite, using a total section at a mile, yes, it will show you an elevation at the end point based on the planet we live upon.
But you do measure straight lines with your line of sight. And do you often use an a theodolite for establishing elevation?
I do, because I work at multi-mile, but when working at a few hundred meters, yes, I use a regular conventional spirit level.
A spirit level? What, not an auto level?
Correct, because mine is 65 years old.
So you use a spirit level?
Yes. A geodetic grade spirit level.
Wow, that sounds nice.
It's expensive.
Yeah, so when you do differential leveling, have you ever heard of double rodding?
All of the geodetic leveling I've done has always been dual pattern, double run, and closed loop with Invar rods and the Jena Ni2 and a Zeiss N2 geodetic level. And I've run tens of miles across big portions of significant Orange County, California.
Okay, now when I just said differential leveling, you went on a ramble, right? A differential leveling run is with an auto level, and it is just elevation checks. It's just for pure elevation benchmark maneuvering, right? Moving an elevation from one place to another, or an established elevation check. Now, double rodding is where you look over 2 points between each transition. Now, those double rodding points are, in effect, a straight line sharing section. To get the accuracy, even more accuracy, they do double rodding in order to show that there is a shared straight line segment as they are tracking along.
Okay, I'm completely unfamiliar with the process you just described, because every time I've heard of using the word double rodding is to use a double patterned rod, a single double patterned rod. Have one rod behind you, one rod ahead of you, and you read both patterns to guard against arithmetic errors.
Well, this is where you read two rods in front of you and two rods behind you. Then when you transition your auto level, you read the two rods. You know, like I just showed you before, there's a shared straight line segment. It's a way of double checking to make sure your accuracy runs are good.
All right, in my 35 years, I've never heard of that process.
How much differential leveling have you actually done?
Hundreds of miles.
And you've never heard of double rodding for accuracy?
I've never seen it in any geodetic manual or in any textbook. Correct.
Okay. I mean, practically, I mean, let me just have a quick check.
And I haven't seen it, and it's definitely not part of the licensing exam. And I have a license since 1991.
Okay. See, it doesn't take me long to find
That is a completely. And if Jesse is still online, maybe you can let him unmute for a second. Has Jesse ever heard of a double rodding reading two different rods at backside.
Copy. I'll put it in the Discord in the Daily Boom. It's just the first one I found. It's a Land Surveyors United double rodding. It is a well-known technique, form of differential leveling in which the continuous check is maintained on the accuracy of the leveling procedure. It's called double rodding. Oh, it said sign in.
Hey, Bev, can I ask Larry a question?
Yeah, go on.
Larry, I just wanted to ask you. You said you've been a surveyor since 1991?
I've been licensed since '91.
All right, okay. So in 1991, when you got licensed, did you ever think in 2021 you'd be talking to people about the Earth being flat?
Oh God, no! God, no! It would be hard to imagine anybody thinking the Earth is flat ever since about biblical times.
But here you are.
Here I am trying to figure out what the hell Bev is talking about. Yeah.
In the nicest way you could possibly imagine, right?
Well,
I mean, Bev said this double rodding thing is a well-known method. I think it sounds good. I want to check to make sure.
Jeremy, I don't know if you know your camera is on. Jeremy.
Oh shit.
We didn't see your ugly mug, bro. We only saw your feet.
All right, no doubt. My dirty ass work boots. This double rodding thing sounds like a very good method for a way of establishing a horizontal line. So you know that you are keeping a horizontal, right?
Double rodding. It sounds like the title of your sex tape.
Yeah, it sounds funny, doesn't it? But I mean, it would make sense, Jeremy, wouldn't it? If it weren't something that they should be doing, they definitely should be doing it, shouldn't they? For a double accuracy check, right? It would make sense.
Yeah, you'd want to make sure you're keeping a horizontal there. I don't know how else you would do it if the instrument you're using has a limitation and you need to move it. Then when you move it, you want to make sure you're still on your horizontal, and I don't see any other way besides this double rodding method.
Right, like one behind the other to keep it and make sure that you're moving along. You know what I mean?
Geometrically, you are having a shared straight line segment.
Quick. Yeah, really quick. Super chat. Oh wait, I don't have any.
You might have to triple rod it, to be honest, right?
In the double rodding procedure, link you just sent is to guard against a mistake, not to establish a higher precision tangent or level or perpendicular or whatever you want to call it. It's to guard against a mistake.
So when you're making a horizontal line, in order to make sure you're not making a mistake, wouldn't you want to use this double rodding method?
Yes, and the double rodding method I use is a 2-pattern rod.
With one rod.
One rod, but it has 2 different patterns. And
yeah, that's not the same though. It's not a shared straight line segment, is it? Because you don't have 2 different rods to have the shared straight line segment.
Yeah, your one rod with 2 different colors sounds like crap compared to what Bev is talking about with 2 rods.
2 patterns, yes.
2 90-degree
whatever,
rods.
2 colors, 2 patterns, whatever.
Yeah, and they're offset, so you read 2 distinct different numbers, and you treat them as 2 separate independent rods, and you run the whole arithmetic on that segment for each pattern to make sure that you end up with only slight differences and not even numeric blunder, some other issue which may have indicated, the instrument, got bumped or something.
Well, we could use a water level and also do like double rodding but double water leveling using the same procedure, which is exactly the method I've just shown.
The method you show, I'd be very, very interested to see how that plays out for you, because I am absolutely confident in the return, and when you see it, maybe you could demonstrate that I'm wrong. You'll have to show me I'm wrong, and maybe it'll show you you're wrong. That's a possibility. You got to admit it.
If you're only using one rod and you move your auto level, how are you going to know you're on the same horizontal?
Because if you read in precision leveling, you use two rods. You have one behind you and one in front of you, and you read within a very short increment of time. If you only have one rod and he's behind you and you read the backside, then that rod walks ahead and you make a turn. Yeah, there is a hazard. And that is why that is not an approved procedure in high precision levels. However, you can do really well if you're, up to the operator to be careful.
As long as the rod has two different colors on it.
No, you can can do this with one rod, but you take 2 points in between the transitions of the level. I'm struggling to understand why you can't get this, Larry. You should be able to explain this, surely.
I think he's thinking there's an error of margin, like a margin of error when you start moving them from one point to
this
another.
shared straight line segment would show that the horizontals do not intersect.
The shared line horizontal segment is a term which is just fraught with ambiguity. I don't use it. I've never heard that before. It's something you created.
What, a shared straight line segment is something you think I created?
I'm unfamiliar with how to implement that in land survey. I only run precision geodetic survey elevations with in-bar rods, auto levels, and/or spirit levels. And when dealing with lower precision at greater distances, I use vertical angles and theodolites. I don't have any ability to come up with flat, because as soon as I ignore curvature, it's chaos. And when I apply curvature to vertical angle, I get the same as differential level. So there you go.
You apply curvature to vertical angles, did I hear you say?
Yeah, exactly. That's how it's done.
How do you apply curvature to an angle? An angle is the inclination of one straight line to another straight line. That's what an angle is. Where's the curvature applied to an angle?
Well, when measuring an angle, you're right, a pair of straight lines, or a straight line measured off the vertical, which is perpendicular to the local horizontal, and I use the trig function to calculate a height difference, and then you have to apply curvature. Now, you can do this in a couple of different ways.
From an angle, Larry?
Yes. And you can do this there's a couple of different arithmetic methods. You can measure the vertical angle, then adjust it by 26 arc seconds per mile, and calculate with that angle, so that you're measuring the chord.
An angle per mile.
Yeah, Bev, you just imagine, put a Lego on a basketball. You can turn the Lego away from you and keep measuring your straight line from your point of view to the top of the Lego until the Lego disappears, and then by then you can deduct that there was a certain amount of curvature because of the.
And that last comment by Bev is just totally outside his ability to conceive that. Yeah, the angle can be the angle to accommodate the 8 inches mile squared can just be calculated and applied before performing the trig function.
I mean, that's what he's saying. I'm not saying I absolutely agree with one side or the other yet, but I'm just saying I think.
Grim, can I just deal with this, please? This is the test, and this is a criticism of the test.
Go for it, Bev.
Larry, the angle you keep talking about, where would we apply that angle in relation to the straight line test that we're talking about on the water levels that we're just marking with a pencil? Where do we apply that angle that you talk about?
I'm sorry, I just got bumped off and I had to come back in. Could you please restate the question?
The angle that you're talking about, where would we apply that in relation to the water level straight line test that I've just described?
Well, given that distance is so short, you're only dealing with, well under a mile, I'd be using angles. However, at multi-mile to like obstructions for navigation or highway construction through rugged terrain, vertical angles for establishing elevation that may be hundreds of feet higher and a couple of miles distant, yeah, you can amend the angle for curvature, or you can just use the trig function and then add the 8 inches per mile squared. There's numerous ways that are all equivalent.
Into the angle, though, Larry. I'm confused.
I know you're confused, and that's the whole point, is you are confused because you cannot open your eyes because you have the cognitive dissonance to not recognize the Earth is a planet. But you're the one who has a cognitive dissonance.
Wow, Larry.
But Larry, you keep saying trigonometry, but you're just saying a vertical angle and applying curvature corrections to an angle and then doing trig to an angle.
Yeah.
But you can't do that, Larry.
And therein lies the problem.
What?
You don't understand.
That you can't do trig with an angle. You can't. We have a saying over at On the Level, right? Pardon my French, Jose, but you can't do fuck all with an angle, right? Trigonometrical speaking, right?
I'm sure you can't.
Mm-hmm. I know you seem to say or seem to imagine that you can do lots with an angle, Larry. You do all sorts of calculations and corrections to it, but you can't do anything. The truth of the matter is you cannot do any trig with an angle. That's not how trigonometry works, and you should know that.
Did everybody hear that? Did everybody hear that you can't do trig with an angle? Bev has just exposed his level of comprehension of trig. Thank you.
We heard it. We heard it.
All right, I got a few super chats to read here. If you guys are cool, I'll jump in.
I'll go back to that in a minute. Yeah, go on.
Yeah, two super chats. I got one for $2 by LB. Things, stuff, and more. Thank you again, Latonya, for the $2. And it's an announcement. I got double rotting T-shirts for sale. $29.99 or 2 for $50. Thank you, LB. Appreciate that. And People for Life for $10. Thank you for the big super chat, People. Babe. Okay, here we go. Are you asserting that every single geodetic surveying textbook that Larry and other geodetic surveyors use is incorrect? And if so, how have you mathematically verified this to be true?
I don't know. Is there something in those textbooks that goes against something that I've said here today that everybody's agreed with so far? So what was it? I don't know what he's talking about. All of these textbooks.
Yeah. As a matter of fact, there's plenty in those textbooks, like the radius of the Earth and how to calculate with angles.
I was just talking about a straight line test with a water level.
Yeah, and the water level will return a constant. The water level will return a constant elevation.
I'm probably having better luck.
Somebody with a very low mic. I don't know who it was.
Still need him.
Oh, Rob, your mic is really low. Now, it was a kind of a moment of silence. I gotta thank you, babe, for coming in, for doing your whole thing, and I want to thank the patience of the globe proponents that was here on the call. I mean, you didn't even have to join, but you pushed through it, and thank you for people that engaged in the discussion, in the interactive part of it, which it was like the whole thing interactive. Yeah. And thank you, Bev, big time for coming in and stepping up and doing this.
Are we opening it up for questions now, or are you shutting it down?
Yeah. I'm gonna let it roll another half an hour. Kind of what we're doing, just kind of open, chit chat, questions and comments about it. But before I concede the floor, one super chat that just dropped is by Kango24 for 5 New Zealands. Thank you very much, Kango. And he say, and I quote, "You can't do trigonometry with an angle.
That's one of the most stupid things I have ever heard, and on this channel, that's saying a lot. Shout out to Kango. He quoted you what you just say, babe, that you can't do trigonometry with an angle.
Yep. Do you want to know why?
Please elaborate if you wish to, yeah.
Trigonometry is a function of a right angle triangle. So step 1, you need a right angle triangle. Step 2, to do trigonometry, you're going to need an angle and at least one of the distances on the sides of the triangle. So hence, for trigonometry, you need a right angle triangle and one of the other angles other than the right angle, which means you need all of the angles really, and at least one side. So yeah, you can't do anything with an angle. You need loads more, don't you?
Bev, in this triangle you just explained, they're all straight lines, right?
Oh, absolutely. You can't have a triangle without straight lines because those angles are the inclination of two straight lines. So you can't have an angle without straight lines. So of course a triangle needs to have straight lines.
I just want to make sure we were all clear.
Yeah.
I have a
Thank
question.
you.
I have a question. In my textbooks, they oblique triangle solution where none of the angles are 90 degrees. That, or you're saying that's fake?
I can't hear what Larry's saying. Sorry.
Yeah, Larry, you're breaking up again, man.
Let me try it, Jose, because I think I had the same question.
Yes.
You say you have to have a right angle somewhere, Bill.
Okay,
can
you do trigonometry with an angle?
If you don't mind, Bill, I'm still talking. If you would let me finish the question.
Yeah. To be fair, let's let Blue because I think he's kind of rephrasing the question from Larry. So let's hear Blue and what he has to say.
Okay, let me try it again. You said you have to have a right angle. Can you tell me what's wrong with the law of cosines? Do you know what the law of cosines is?
Cosine is the relationship of one side of a triangle to the other in relation with the angle changing of a right angle triangle, right?
The law of cosines is how you calculate things with triangles that are not right triangles.
Are the triangles that in this thing, they're all still straight lines, right?
It's Sakatoa.
Blue, are those triangles, do they all have straight lines?
You see that? I've just put a thing in the Daily Boom. You see that's the cosine wave in it, the cosine and the sine wave of the triangle within a circle.
Okay.
Yeah,
that's it.
Would that be a right angle triangle within the circle? Right now, okay, you can devise a method using triangles because it's always a right angle triangle, right line geometry, right? We do this. So it always relates back to the right angle triangle whenever you do anything, especially with trigonometry, cosine and sine, tangent. That's the three sides of a triangle, a right angle triangle within a circle and the relationship of the circle to the triangle. So but can we get back to the original point, which was you can't do anything with an angle? Can you do, what trigonometry are you able to do if I was to give you, let's say, an angle of 33 degrees? I would say, here's an angle. I'll hand it to you. Off you go. Can you do trigonometry with that angle?
Of course not.
Okay, so the statement still stands. What I said originally, you cannot do trigonometry with an angle, right?
Can't do fuck all with it.
Larry was talking about something completely different.
No, he wasn't. He was just talking about an angle and doing all sorts of trigonometry to an angle. What were you talking about, Larry? Please. We go back over it at some point, I'm sure.
I got a very big statement and a very good solid super chat by Mr. Grimm. I want to read it. It's a big $20 by Mr. Grimm. Biggest super chat today. Thank you, brother. And I quote Mr. Grimm: cheap wear masks. Open your shops. Rebel the lockdown. Shout out to Mr. Green. I think I agree with your statement. Ship, wear masks. Open your shops. Rebel the lockdown. Thanks, Mr. Green.
So yeah, we can't do anything with just an angle. So anybody that tries to fool you with some sort of wizardry, waving angles around, saying they can measure radiuses and doing all of that from just an angle, they'd be ridiculous. Especially, it's one of the things that we've been doing just recently is with the horizon, right? The only geometrical thing we can say about it is it's horizontal. You can't measure a distance to it. So measuring an angle to the horizon would be about as far as you can get. That's it.
And
One angle.
I don't measure vertical angles to a horizon. I measure angles from zenith, so from a known orientation to zenith, from zenith to an object, and I know the distance to that object. I'm only calculating elevation. Then I have one dimensional with two inputs, so I have my degrees of freedom have been satisfied.
How did you measure the distance?
That could have been any of 100 ways. I could have pulled a tape
just
measure.
Give us one of the ways. You've got a tape measure.
I could have used a tape measure. I could have used my laser, and I could have used published coordinates. I could have gotten my own coordinates by GPS methods. I could have used phase differential to get a GPS. Any one of those. I have the distance, and the distance is reliable. That's not in question at this point. If you want to talk about how we measure,
would that be a horizontal distance?
Well, I
like
use
a horizontal distance and a vertical height.
Yeah, I open up any of those.
Making a right-angle triangle, right at the base where the horizontal and the vertical meet, because the perpendicular.
Yeah. Okay, and then apply the angle that brings us to the chord of our 3,960 mile radius planet that we live on.
That right angle of that triangle would be in the distance, wouldn't it? So the horizontal that you send out with the vertical height at the other end would be a horizontal distance and then a vertical height, establishing a right-angled triangle, right? So that would be a perpendicular to the horizontal at a distance away from you, wouldn't it?
As long as I apply curvature corrections as required by distance, yeah, elevation change and distance.
Curvature corrections to the horizontal, or what curvature corrections to what? Like you've got a horizontal distance and a vertical height, right?
And a vertical angle.
Yeah.
And a vertical angle. So I got an elevation.
And an angle, yeah. Okay, so you've got a right angle triangle with a horizontal distance and a vertical height and an angle. So what is it that you want to calculate?
The elevation at the distant point.
You said you've got that. Oh no, you've got the distance to the object. You've just not measured the height of the object when you measured the distance.
Correct. And that is a requires different categories of information. One is a distance and one is an angle.
What's the normal things that you have to measure the height of that you can't do from where it is? Why can you not measure the actual height of what it is that you want to calculate?
Because it's a 400 kV power line and I can't get within a half a mile of it and I can't touch it with a rod and it's 500 feet above me. Yeah. Or a radio mast with a light on top, which is a navigation hazard to navigation, and the FAA requires that a licensed land surveyor execute the appropriate surveys to determine its elevation above sea level, and I can't get within a mile of it. Yeah, and it's 1,600 feet above me. You bet there's going to be some computation involved that is not going to just pretend the Earth is flat, because that's a hazard to navigation. And the towers that I have been measuring are in proximity of Camp David to where our president's helicopter has to fly. And yeah, trust me, those are well-known and published elevations And yeah, I can measure it from 20 miles away and get within plus or minus like 3 feet after applying a couple of
The
hundred.
elevations are already published, or you've had your elevations published.
I calculated the elevation, and then I checked my work against the published, and I was within a couple of feet of what they said, and I did it from miles away. Yes, that's what I did.
Okay, it just as a hobby, right?
As a retired land surveyor that happened to have purchased a whole bunch of very high-order equipment. Now, in that case of that radio tower, I got as close as 1 mile. I got as close as 1 mile and as distant as 27.5 miles, with 15 or 18 points in between.
Okay, to measure the elevation of the tower. Is that what you were doing?
Yeah.
Were you not sure? You're just double checking.
No, I said so. I am measuring the elevation of the tower, and I started when I was close, 1 mile away, and I progressed with about 20 points to up to 27 miles away. And if I don't apply curvature, it's chaos. And when I apply curvature, I get one uniform constant elevation with a standard deviation of about 1.9 feet at standard deviation, which is almost 3 feet.
Did you just get a unicorn?
What?
Did you say unicorn?
No, I have no idea where you came up with that word.
I could have sworn I heard you say unicorn. You get a unicorn. But, I mean, so you measure the elevation of this tower, and your conclusion of measuring the elevation of the tower is what? What conclusion do you come to?
I come to the conclusion that the curvature and refraction is evident in my own measurements, and compared to all those textbooks are very, very high agreement. So if you have a problem with what I'm telling you, then as was pointed out, you must have a problem with every institution and textbook. So bring it up with them.
I'm just a little unsure about what you're actually saying, Larry. I don't know.
Larry, have you talked to Bev before?
Nope. This is new territory. I have no idea where this cat's at.
All right, well, have fun.
I didn't.
Okay. I'm curious as to because we're talking about this straight line test, right? How do you make sure that a straight line is a straight line?
Use light like John proposed.
Just a line of sight, then.
A line of sight, yes.
Okay, so double rodding techniques would also work good at the side of this water level test that I've proposed with the water levels.
Right, yeah, go right ahead. Let's. I'd like to see all methods and all technologies poured into your pissy little 400-meter water level, which will absolutely show 3 millimeters of arc at the middle. Yeah, or whatever the number was. I forget.
It will show 3 millimeters of arc. Do you say?
I think so, or whatever that number was. I'm poorly remembering.
Okay. But yeah. So, good. It's there to be measured. That's all I want. That's all I wanted. Yes. Thank you. Thank you, Larry.
Yeah. And when you find it, you'll know that it's accurate. And when you don't find it, then we're wrong.
Who's wrong?
Yes, but just remember, you can't make a straight line from 4 segments that we claim. If you remember from the second model, that we claim they are a chord inside a curve. You can't claim those are straight lines.
Have you ever seen a Dornagon?
What?
Have you ever seen a Dornagon?
I don't think so.
No. It's a conceptual mind shape. Shout out Dawn. I mean, genius. It's a conceptual mind shape that is made up of 2 or more shared straight line segments. Much like the horizon, right? Because that is, every time you look at it, no matter where you look, it's a horizontal. And you just add all of those straight horizontals up, and you can imagine it's a circle. See, this is a conceptual idea of the water levels all being straight lines and having shared straight line segments, but also you being able to imagine them being a circle.
So we need to find a way to tell, are they a straight line or are they curved?
Yeah,
you
that's
can't
exactly
use
it.
them. You can't use them as a straight line and tell us, you see, no, we need a
Bev, with this
straight line.
Bev, with this double rotting method, how certain can we be that we will keep a horizontal straight line?
Absolutely, and this is geometrically how to show a shared straight line segment. I mean, in
He
reality,
didn't understand the question, Jeremy.
Bev, is the presentation over so we can talk together or what? Beef, is your presentation over or so we?
He's in the middle of asking Bev a question, I think.
Am I beef?
Sorry, I
Yeah,
was laughing.
I know, I love it. Yeah, I like that. That's good.
No, it was a fucking question. Is the presentation over?
Is what over? I don't know. What was the question? Can somebody state the question again? It turned into a bit of a.
I'm your flattered friend asking you, is your presentation over?
Jeremy was asking him a totally different question.
I know, yeah.
The officer
He's just answered it.
His presentation is finished, and yes, I think it has.
Bev answered my question. I don't know why the guy said he didn't think Bev understood my question. Bev understood it and answered it.
It sounds like Louis. Louis's been
Because
through
your
this. He didn't get
question-
this
because-
far though. Louis' cog disc was.
And Louis, you
slightly
broke up there
different.
big time.
His question has to do with how is Bev going to determine the line is perfectly straight? And Bev's answer to that was, well, I'm just defining that it is straight, so it's straight.
No.
All right, let me rephrase the question.
Can I just restate that then again, Louis? You might have not been here at the beginning, although you were. You did go through it the other day over at on the level, right?
Yeah, and it's clear to me
so
that you don't.
At
You
the
actually
beginning,
don't
when we
understand.
said from a straight line is from a point to a point, did
Right,
you
yeah,
agree
you're
with
just-
that?
you're
You
just
did,
defining-
didn't you? I remember
you're
you
just
agreed with that.
defining-
Yes.
Don't talk over me. You've
Wow.
just defined that the line you're measuring is straight, without actually proving that it is. And Jeremy's question was, how are you going to determine that when you make a line in reality, it is actually straight?
With the double rotting method.
Yeah, if I may, I asked the same question.
No, hold on, Craig. Hold on. Bev, how sure? Let me rephrase the question. How sure can we be when you measure this straight horizontal line that it is straight and horizontal with this double rotting method? Maybe that's more clear for Louis.
Yeah,
Louis the Lion.
Okay, so when you find proofs of anything, you have to have an understanding of what you're dealing with in first. So that's why we started off at first principles. So a straight line is defined as the shortest distance between 2 points. Now, all you have to do with that is take away a couple of the middle points and check out whether the straight line is the same and whether all of those points lie upon that straight line. Now,
How you do it?
Kindergarten. It's so childish. Are you stupid people? It's talking about very simple things.
Yeah.
To answer your question,
It's the difference between talking about it conceptually, John, and actually demonstrating it in reality. So we can talk about platonic shapes and geometry and how things are perfect in that world. But now what we're doing is we're trying to apply a straight line in reality. And I think
We
that
were
was the
talking
point
about
of the
measuring it with the double rotting method.
But
in
you're so
reality.
childish. You're so
Yeah.
childish.
Just-
It's very simple.
Just what do you class as a straight line then? in reality.
Listen.
Shortest distance between 2 points.
Okay. The
Brilliant.
shortest
So that's
distance
what we've
between
just
2
dealt with.
points. But 2 straight lines do not imply 1 straight line.
A shared two
How
straight
do
lines
you
cannot
convince
share a common segment.
What? You claim it's a segment. I'm telling you there's an angle between them. Prove me I'm wrong.
You are
Two
always wrong.
Straight lines
Your
cannot
motto is wrong.
share
Look,
a common
you connect
segment.
2 points and then you connect two other points and you say it's a shared line segment. No, it isn't. I'll claim that it's 3 line segments in fact.
Okay. You claim, right, horizontals intersect at an angle, right?
Again,
that
we're not
angular
talking about
deviance
conceptuals,
of a
Bev.
horizontal, what is it, please?
No.
Yes, that's what you've just said.
2 points at the same level do intersect.
Yeah, I think
the
I
problem
got.
is,
I got
again,
some
you're
insight.
taking a conceptual object and you're trying to enforce it in reality. And what we're saying is, how do you validate that your concept equals what you're doing in reality, Bev? So don't talk about the conceptual side of the line. Let's talk about physically how you're going to establish it. I think that was the point of the question.
Okay.
Yeah, I think I got this.
How about something like
the channel, Bev? Remember the channels?
If vertical is a right line of unlimited length, P, then all perpendiculars to it will be horizontal, Q.
Mm-hmm.
How about that?
Yeah, but now you're taking multiple measurements and you need to maintain that straight line, don't you? And
No,
it's
just
when
that's
you're
just
making
horizontal
those
and
changes,
vertical are
and I'm just going to
perpendicular.
finish my point, but thanks
do you want
for
to
that.
disagree?
Carry on, mate.
Go on.
I don't know. I didn't listen to what you said because you overtalked me.
Okay.
I don't understand how you can talk about things like this is something. It's very, very simple. Straight is straight, and curve is curve. That's it.
Hey guys, really quick. Go ahead. Finish that thought. I gotta say.
Okay, when I did this presentation with Bev on the server, I asked kind of a similar
Do you
question.
mean you
and he
did
talked
this presentation with Bev?
Well, okay, with you, yeah. I asked about the
you
same
didn't
thing.
do this with us. You've never done this.
Yeah,
Correct?
and I asked the same thing, and you told me about the channels. There's like a channel for boating along the side of like a roadway, and you were going to run it along that.
Crit, stop lying, please. You've never gone through this with me. I've never talked about a boating channel at the side of anything.
Yeah, you showed like a map, and you drew a line down the map with the waterway.
He's probably talking about the Bedford level, Bev.
Yeah, but he hasn't done that with us. I don't know.
No,
he must have been
wouldn't be
dreaming at
surprised,
some
mate.
point, Crit.
Well, I remember.
I haven't got a clue what you're talking about.
Yeah, that's what I'm saying. I must be
must be
I
something
don't know what the
you've
deal is. Why you
dreamt.
want? No, I remember specifically. You had the map up. You said this is a channel. This channel is level. It's got locks here and here. If this water it runs along this line, and then you drew like a red.
Crit. Sorry.
Yeah.
You said this presentation, and then you start talking about something else. Now,
Yeah, did you take that part
are
out?
you talking about this presentation? When was that? Wherever you dealt with this is about a water level tool, right? Where is a canal and locks in this presentation that you've just watched, please?
Yeah, at one point I think you had that slide in there about the locks. Maybe you took it out.
Where?
Can we get back to the?
Wait, Bev.
Crit, stop talking and making stuff up, please.
No, it's not Crit, it's Chai. Last time I saw your video when you hit the tubes there. Remember you made the video and there was a canal right at the side.
Oh, there was, I've done many other videos. I've done loads of other tests actually at the side of the canal. Yeah, that's the best place to go because
that's what I'm
got
talking
some
about.
nice
What the
level
fuck?
ground. Well, that's not what we've just done. What we've just done is a presentation about a shared straight line segment.
Yeah,
Chai,
this is a new and revised test. Okay.
Yeah, Chai,
Okay.
you
Can
hear
we
me.
get back to it, please? Can we get back to it, please? So, Bev, and when you're going to measure this straight line in reality, we're going to use this double rotting method. You're going to use the double rotting method. That's how we know we
No,
will
no,
have a
no.
straight
I'm
line.
going to do exactly what I've just shown you, guys, with the water levels and some posts and a pencil and a mark. Right now, it's up to you guys what you think of it. You can judge for yourselves what you think of it, whether you're going to want to do it, whether you want to make it better, or when you want to do whatever you want to do. That is my test that I've devised to make as cheap as possible to prove to myself that level is a straight line on a horizontal plane. That's it. I've just shown you guys from first principles a method. Now you can judge to do whatever you want with it.
Yeah, your method is flawed.
Which one of the two methods are you going to use?
Sorry, I didn't hear that.
Which of the two methods you have presented are you going to use?
Which two methods? The one where I showed you 400 meters and we moved it across with the 3 posts.
So the last one then, not the one in the presentation.
Which presentation?
Didn't you have a presentation at first, and then you went over to a whiteboard?
What do you mean in the presentation at first? When I was showing you that when I said a water level is a tool for establishing a horizontal plane of reference, that one.
Yeah, when you had this
that was one of DP's memes. Shout out DP. That's one of the best ones. That. Yeah, it's just a factual statement. That it's a meme. I know DP's memes do trigger some people, but yeah, that was a meme, and it shows you how you can prove that there is no hump with the water level.
Me, I'm not following you now. What do you mean by what meme?
Right, what are you talking about? Please state the part that you are actually talking about in the presentation that you've just watched. Which part are you talking about?
As I saw it, you presented 2 different models of how to do it.
I showed you the globe model paradox of the Kozlowski nutsack drop model, as opposed to the Kozlowski-Bislin
if you are going to insult
model.
people that aren't even here, then it's
we can avoid that. We can end up well without the kind of name calling. Maybe call him George.
Yeah, that's just the model. That's what we call it.
So the first one you had presented, which had 3 different tubes, that is not what you're going to do.
The one with 3. No, that was to show you about the hump, how ridiculous that hump is. You mean that one where 23.7 miles?
I didn't see any measurements on it.
Did you not? The hump or the drop model where it had 8 inches down the side?
No, I didn't see that. I didn't see any measurements.
Okay. So are you just talking about the one that was just a shared straight line segment then?
One with 3 different tubes.
3 different tubes?
Yes. It was in black, in red and blue.
Okay, yeah, that's the meme, right? The one little graphic that DP did for that bit said it was just to show that a water level is a tool for establishing a horizontal plane of reference. So that wasn't a test. That was just a graphic.
So everything in the presentation was just a presentation of something that was not going to happen.
I don't know why. Why do you say that? Like a level, a plumb bob being a tool for establishing a vertical. That it definitely does happen in reality. A level being a tool for establishing a horizontal, that definitely does happen in reality. Horizontals being parallel to the plane of the horizon is definitely happening in reality all the time around us.
This test you're going to do, you're going
to
set up first
400 meters. I did explain it. Did you see that bit? Where I explained 100 meters.
I was trying to follow it, yes, but I had to stop and just go away and laugh for a bit some of the time.
Okay, well, you'll have to just go back and watch it at some point, right? I think if everybody else, did I explain it well enough? or does it need
So
going over again?
You're first going to set up the experiment and then move the experiment. Is that it?
It's not an experiment. I think you must have missed the bit where I explained it's not an experiment. Right? You can't do an experiment by marking a piece with a pencil.
What is it if it is not an experiment?
It's just a test. It's a show.
Okay,
a
it's a
straight
test. Okay,
line.
yeah.
Yeah, it's It's a geometric test in reality to show a straight line, a shared straight line segment.
Hold on.
So you're first going to set up the experiment.
No, I was saying, hold on.
Yeah, I know. You're calling me.
We're getting. We're getting it riled up. It's a little. I was gonna wrap it up like in the 2 hours 45 minutes, so we can have final thoughts. But we already passed the 3 hours and 20 minutes mark. So I think it's a good time to do final thoughts. So I'm gonna call everybody. It's a lot of people in the call. Everybody will have a chance. Take 30 seconds, wrap it up. Take your time, but don't go like minutes long. Final thoughts, and then we'll get out of here. You guys can stay in the after show, can stay in the call, and we'll take it from there, man. But we need to wrap up the YouTube live show because it will take a long time to render and be uploaded for everybody. So,
okay.
Thank you everybody for watching. Yeah, perfect. Thank you everybody for watching. It was fun. It was good. I made some money today. That was good. I'll take it. And we'll do it all over again tomorrow. I'm gonna try to contact Lemon Bird and see if Lemon Bird want to take the floor tomorrow. We got a Lemon Day tomorrow, hopefully. If not, it's still Flat Earth Week until Sunday. All right. Artrexis leaves. Do you got some final thoughts for us? Are you even there? Beard the Devil. Bev Try Thinking will go last. Let's go with Big Blue. Buster, final thoughts.
Just shout out to Bev. Learned a lot around those guys and good presentation. Thanks. Good show too.
Thank you. Chike, final thoughts.
Bev began his presentation with cognitive dissonance. I think he should look at the mirror. Thank you for the good job.
Thank you, Chike. Crit, final thoughts.
Ho ho ho.
Thank you. Ed Freeze, final thoughts.
Right. The Earth is not flat. Bev still didn't explain the difference between evidence and proof. And let's see. I don't think I heard a valid test in this whole presentation of 3 hours or however long it was. So maybe you can try it again. Thanks.
Thank you. Mr. Victory can't VC right now, but his final thought is the Earth is not flat. Thank you, Mr. Victory. Thank you again, Ed. Hold on. Final thoughts.
Yeah, it has been a lot of head shaking for me today. It's just unbelievable what I've heard. I'm just lost for words, really. Thank you.
Thank you. And just in your behalf, I'm gonna let that update notification to pop up every time just to piss you off.
Yeah, that's good. we need some entertainment, some good entertainment.
Right.
You know? Yeah.
All right. Thanks, man. Thanks for your heads up always, man. Let's go with Jeremy. Final thoughts.
Jose, you seen Jim dripping with the super chats. Now you're trying to make a puddle. Anyways, good shit, Bev. Good shit. That's all. I'll see you in Brandon's in about 40 minutes.
Thank you, Jeremy. John Bernards, final thoughts.
Thank you very much. I'm newborn. Just absolutely different. I have a new thoughts, splittery new. And I thank you for go on. So great it has been to this Sunday. Thank you very much.
Thank you, John. And I want to welcome you tomorrow. If you want to come in earlier when the show begins, I would like you to share some songs with us, bro. Piano songs, if you can. I would really appreciate that. I want to hear you playing some piano for us, bro. That's cool. So if you catch the show tomorrow, just jump in, man, and be ready to turn your camera on and share some goodies with us. You're a really good musician, like for real. I mean that. You know.
Thank you.
All right, let's go with Kid Motorbike. Final thoughts.
The big takeaway has to be that we're going to have to rely on Rompus to actually do a test. Thanks, Jose.
Thank you. Shog. Final thoughts.
What's going on, man? Yeah, I thought the test was pretty dumb. Sorry. You could just do a Bedford level test and accomplish the same thing. Possibly just do slice bar cadence test and actually accomplish it. But the whole thing with the two concentric circles, I don't know how you would expect that to be the conclusion. But hey, good luck.
Thank you, Coach. Before I forget, guys, you did excellent on the Daily Boom chat earlier. I said, like, you know what? Don't type any controversial topics, no personal attacks, no swearing, no profanities. You guys did amazing. Little bit of trolling here and there, but you guys got the controversy room to do everything else. Thank you for keeping the YouTube the Daily Boom chat for small talk and having fun and trolling, and same for the YouTube chat. Thank you for keeping it somehow decent, without going too harsh on anybody. I thank everybody for that. Larry, GPS, final thoughts.
Well, the test would be just fine. He needs to do it, and when he finds that in his whiteboard there, where he drew the red arc and the blue arc, he'll find that they're concentric. And if he doesn't find that, well, when we stand corrected. But we know better. The Earth is a planet. South Pole exists. Sunrises and sunsets. I mean, these things are not frontier science. So knock yourself out there, Mr. Bev. I'll be looking forward to the results. And why not stretch it out? Go 2,000 meters. I mean, come on. Why go small? Put on your big boy pants. Oh.
Thank you, Larry, for hanging in there and participating, man. Lori Letiaho, final thoughts. You heard any of it?
No, I missed most of it. But I wanted to address this idea that we have two models, supposedly one for the hump and then one for the other where it's more like a tangential. Of course, I actually posted a picture kind of visualizing this in the side chat. The only difference is the tilt of the camera. So if you draw two lines from the eye of the observer and draw one tangent or one actually cutting into the shape. So you can create both by just using one model, which is of course why Dev is full of shit.
Thank you, Laurie. Appreciate that. I had the first time out, the only time out today from Truth Hurts in the YouTube chat. My apology, but I had to time you out for that, man. No good, brother. Whether it was funny, but if it's taken out of content, it has some heavy words in there that the only thing to delete it is time you out. So throw responsibly, guys. Okay, let's go with Mailman. Final thoughts.
Good show. No interruptions or anything. And level is a straight line if it's on a horizontal plane. If it's not, then it's not.
Thank you, Mailman. How about Moyok Man?
It was an interesting show. I enjoyed it. It was nice and calm, and I just think that it didn't accomplish much. I was hoping for a little more. That's
Thank you, Moyok. Yep, thank you, brother. Mobius, final thoughts. NBD, final thoughts.
At no point in what Bev said in his rambling, incoherent response was he even close to anything that you could consider a rational thought. Everyone in this room is now dumber for having listened to it.
Woo! Shots fired. Raki alive. Final thoughts.
Yeah, I don't want to take anything away from Bev today. I will say whoever just spoke is probably a troll only. We need to free all the nuggets. All nugget lives matter. I don't know what the word is for people discriminating against nuggets, but they shouldn't do it. That's not the world we want to live in. Free the nugget. But getting back to Bev, unbelievable how people can't get this. I think it's so simple. The smart guys just can't get it. They're just too smart. Indoctrination has got them. What's that word? Cogdis. You saw a couple blow ups. They just lose their mind over something so simple. These are tests that you can go out and do yourself. They're not expensive. They're repeatable. It's what everyone's been asking. We have a certified surveyor in here that will tell you the slab of a building is following the Earth's curve over a mile, and that the best way to create a horizontal is by using GPS. But when you create that horizontal, at some point it's going to start curving, because if it didn't, you can measure the drop from that horizontal and know you were living on a flat plane. Pretty much it. Have a good day. Good show, Jose. You see what it can be like.
Thank you. Rob King, final thoughts. Okay, we got Sean Smith. He's in his office, and his final thoughts is go do the test. Thank you very much, Sean Smith. Who else is here? Domesticated primate. Final thoughts. And last try. People for Life, you just rejoined. You were here earlier. Final thoughts.
Yeah, I'm going to have to go back and re-listen to this. I'm not sure if Bev actually explained what he was going to do. If he did, I'll go back and see. But again, I agree with Rocky. This test is inexpensive and can be done by anybody. So we are patiently waiting for the results. If it ever actually happens. That's all I got.
Thank you, people. Last chance to Bearded Devil.
There are no valid arguments for the flat Earth, and Bev's is no exception.
And last chance to Big Blue.
Jose, can you hear me?
Oh, there you go. Who was it? Who was that? I heard somebody.
Sounded like some kind of primate.
Oh, okay. Primate, go ahead. Final thoughts, man. Oh, I heard you for a second. Now, no more.
Am I back again?
There you go. Yeah.
Yeah. Well done, Bev. Nice presentation. Anybody who doesn't understand what was said in here tonight doesn't understand the basics of geometry, and that's not Bev's problem. That's not anybody on the level's problem. That is your own problem. You need to go and figure it out for yourselves.
All right. And two more. We got Blue Marble. Are you back for final thoughts? No? Well, man of the hour.
Jose?
Oh, Rob, right? I heard low mic. That must
Yeah.
be you.
Yeah.
Final thoughts,
Yeah,
man.
it's Rob with the low mic. I'm sorry. Hey, thank you for having us. Appreciate it.
You got it, man. And before we go with Bev, Beeble for Life. Maybe you want to do a quick video on trying to figure out what went down. And Bev, you probably want to make a video, either upload the whole thing or clip it or something. The only request that I ask on my videos, anybody can share it around. But I appreciate it if I get a mention, at least a link in the description box, like, hey, the original happening, Jose. That's all I ask for, and everybody's free to use any of my content. So anybody, please feel free. Bev, try thinking. Final thoughts.
Yeah. Thanks, Jose. I mean, yeah, of course I'll give you credit for this. I mean, this is where I first gave the presentation. I will. If anybody, like DP says, if anybody wants any to go over it or anything like that, wants to give us feedback, you'll have to go to Cleary's Discord channel, because Emma's locked down on the level. Only admission only by request and at Emma's discretion, which I'm fine with. It's good. I prefer it that way. So if anybody wants to have a chat from now on, it'll probably be either over at Nips or over at Cleary's Discord channel, the Right Line Geometry. Especially if we're talking about this geometry stuff. I'm quite eager to hear any feedback Anyone can tell us anything about what they imagine that they might happen, or if we could improve this test, if you think we could improve this test. The idea is that it's checkable with the numbers that we've been given. Then I can do a 400-meter test and personally prove it to myself. Somebody else can do their 400 meters test, and then we can go together and join the two together and do an 800-meter water level test. I mean, at the minute, nobody really seems to understand who the experts are about water levels. Definitely not the surveyors. Surveyors don't know anything about water levels. Wherever we've asked anybody, when we've done our multiple conversations about leveling and stuff with surveyors that we have had conversations with multiple surveyors. They don't know about the water level. So this is us doing a test with it. And we're also applying geometry, basic geometry, with an understanding of logic from reality. So that's all we do. Also, I'd like to say MBD is the reason I personally left Gem Pandas last night. I will not tolerate people calling other people horrible names just to get a rise out of them. Trolls. They're not needed in this situation. So thank you, Jose. You've done a really good job today. I hope that you don't get a comeback from the people that want to cause nastiness between people. And long may this continue. Right? Thank you.
Yep. Thank you very much, Bev. And yeah, I mean, the plan is to give microphone priority to flat Earth, to non-globe proponents these few days, and then I'll go back to do the open panel so everybody will have the same equal opportunity to talk. So it's gonna be more of an even side. Hopefully, we get participation from both sides. This is strange because I read Essie Montreal, the comment that caught my eye. Essie Montreal say, this show shows how people on this channel are delusional. You might be talking overall, but today was kind of on the level team day. And I tell him, like, dude, are you calling Bev and his team delusional? And he answered me, it's too bad. I thought I had hope on you. So I'm confused, Essie Montreal. Maybe you want to join the after show and tell us about it. But I got a last super chat by Vivo for Life to wrap it up. Somebody's hot micing over here. I got a last super chat by Vivo for Life for $5. How much expertise do you need to understand a simple water level? I'll leave you with that. Ladies and gentlemen, Jose JG out. Boom!
Boom.
Thank you.
I'm just curious why a surveyor would want to use a water level.
Yeah.
To establish a horizontal. Anyone interested in establishing a horizontal frame of reference might want to use it.
No, it's pretty useful when you're trying to level a piece of equipment. I've been using them since the early 1970s, probably before most of you guys were born.
Mm-hmm.
They were really pretty good for short distance
Establishing
stuff.
a horizontal, right?
Become a major pain in the. They become a pain in the ass. You try to cover. Why don't you shut up, John, and let me? Why don't you shut up, John, and let me finish what I was saying? They become a major pain in the ass when you start talking about going hundreds of meters, and you're going to find that out.
How big's your longest water level you've used, Blue?
Probably 75 feet or so.
Okay.
The best use of the water level that I've seen is in large buildings where they walk around to make with a water level on a height staff and leveling up like ceiling tiles where they have to go around walls and around, all over the place without line of sight. So yeah, that works really, really well. And yeah, a water level, absolutely, a very, very high precision tool, without doubt. You want to string one out 3,000, that'd be fine. And you put 4 or 5 uprights in the middle, yeah, you're going to have a constant elevation. And a constant elevation is water seeking its own level. And yeah, that's all those points at the meniscus and all of those uprights will form 3,960 mile arc, radius arc. And if you sight from the beginning point to the end point, you should see the ones in the middle a little bit higher, just like Wallace did on the Bedford levels back in 1870, whenever.
Did you just say level is a circle?
No, I said level is a constant elevation of 3,960 mile radius of the Earth, of the planet, because the planet is in hydrostatic equilibrium.
But that's how you describe a circle, right?
Okay. Yeah. Because
constant distance from a center.
The surface of water is a three-dimensional surface with a radius to the center of the Earth. And in your graphic, when you drew the red arc and the blue arc, you mistakenly did not draw them concentric.
Did you just say a hydrostatic equilibrium is a circle?
Is the planet, yeah.
A hydrostatic equilibrium, water at rest.
That's the definition of a planet, is large enough for the gravity to form into a sphere by hydrostatic equilibrium. Big Blue, help me out.
Wow. No, you got it.
Come on, Blue. Help him out.
That's a very good description.
So a water level then is I say a horizontal plane of reference. You say an arc.
Yeah.
What about an even altitude?
Constant elevation. Yes, correct.
Horizontal and constant elevation are not the same thing.
Horizontal is a tough word to use because it's very local, very regional, and depending on the precisions you're dealing with, if you're dealing with plus or minus a quarter inch, yeah, it's just a simple straight line. Yeah, you can just put your auto level in the middle and look for hundreds of feet in all direction, and you'll be just fine. If you're grading dirt or laying asphalt, yeah, but if you're doing something of very high precision and you have to carry that elevation many, several miles, yeah, you have to move the instrument incrementally and be careful. And yeah, it's because by moving the instrument at a couple hundred feet at a time, yeah, all your little straight line chords, yeah, do not accumulate.
Shared straight line segments, though, right? Make sure you get that shared straight line segment all the way along. Make sure it's a straight line.
Bev, are you going to be doing this test in the water or what?
What?
Are you going to be doing your test?
It's a water level. The water is in the tube.
That's nice. That's not what I asked.
Well, what did you ask then?
Are you doing the test?
Can I ask a question?
In water?
No, I'm doing a water level test, right?
Yeah.
Why?
Are you doing that in water?
What would be the use in that? No, I'm not doing it in water.
Hold on, why not?
Because it's a water level test.
Yeah, I got that part. All you're doing is making sure that the water level works. That has nothing to do with anything other than the instrument itself. So how are you establishing this as an argument for the flat Earth?
It's not. This is a straight line test, Bearded. I mean,
yeah, but
what do you seem to think it is?
Water. Hold on. You're saying, okay, so water is level, and a water level is level if it's level with the water. You would agree with that, right?
No, the water is the level. It's brilliant.
Really
you want to see it. You don't understand, do you not? That
it
is the water that establishes its own level. The tube is just a container for the water.
Yeah, I got that part. Doesn't really matter. Why aren't you doing this on the surface of water with the water level?
Because I'm just doing a water level test to show that a straight line segment is shared.
Has nothing to do with the Earth being flat or any other shape.
Again, I'll say it again. You are the one, right, that said you're not bothered about the shape, right? Why are you asking me that a straight line test that I've just shown you about how a water level works from first principles and just going through water levels? I didn't mention the Earth at all once. You're the one that's
why I'm
mentioning the
curious.
Earth.
Then why are, just out of curiosity, if you already know that a water level works, right? Then why are you making sure? Are you going to calibrate it or something? Are you questioning whether or not that a water level functions?
Do you know, at the beginning,
Because it seems strange
of all of this, Bearded, right? Somebody once said to me that I was a child abuser. In fact, somebody said it. That same person, right? That same person said it to Rakia the other day over in Gem Panda's server.
I still don't care.
Right? For the
You're going off topic.
For the same reason.
You're still going off topic.
For saying that level is a straight line on a horizontal plane.
I still don't.
Do you have a proof? Do you have a proof that
you're just switching
it is or
here,
it
man.
isn't that?
Come on, dude. Are you arguing that the water level doesn't work?
No. Somebody challenged me.
I don't care. They're challenging you to see if a water level works.
And then saying you don't care when I try and answer. What's up with you, Bearded?
You displayed a water level. No,
you
displayed a water level. This isn't cognitive dissonance, dude. Me questioning you is not cognitive dissonance.
Just let me answer then.
You want to... Because you're complaining about what somebody else
said. Why do you not want to let me answer?
Because you already answered. And I don't care about your issues with someone else.
Is it the same guy from the beginning that didn't know the shape of Earth?
Yes, this is the guy that has now gone all the way through something that wasn't ever about the shape of the Earth. It was just about establishing a baseline of understanding that we can build on.
What?
This is the guy who asked Bev why he's doing the test and presentation, and then said he didn't care why Bev was doing the test and presentation. We just heard it.
Not the philosophical reasons
why are you doing this test? I'm doing it to prove to myself that horizontal is level because someone called me a child abuser for teaching my kid
that's exactly not what he said.
I don't care why you're doing it, Bev.
Yeah.
What an idiot.
I don't care about the philosophical
right.
reasons. The emotional shit I don't give a fuck about.
That's his reason, you moron. That is his reason.
Stop crying, Rakia.
I'm not crying. I think it's unbelievable how smart people can understand. Bev, why are you doing this test?
Okay, I came in running too because I don't want to hear this term spoken in this channel, the term child abuser. I don't want to hear about that. The topic. Rakia, you can talk over talk and rumpus. Don't bring the personal topics up, please.
He did. He asked me, right? If anybody ever asks me why I'm here, that is the reason, right? I'm not here because I wanted to go and have a good chat or go and wash my feet with people. I didn't do that. I'm here because I was on Twitter finding the most horrible, vilest people. And they said stuff to me. They still do. They say it still. We left a server the other day, yesterday, because of that very thing. That same person saying the same thing.
That guy is here today in your chat, Jose. The reason we left the server yesterday, that guy is here today in your chat.
Who is here. I don't care what happened somewhere else. We're having a good chat today.
Okay, that's fine. That's fine.
Okay, right.
Just be aware.
Don't let them ask me a question and then not let me answer it with honesty.
Bev, I've already clarified. I wasn't asking for your philosophical reasons why you're doing it.
Okay. Well, I'm doing it
so that was irrelevant to what
something that I stated as an obvious fact that I had no proof for. I needed to find a proof for myself. Now, how do you find proof? First off, it's a massive journey, right, that you have to go on in order to prepare yourself for this. Because I can guarantee 95%, well, no, let's say 80% of the people that are here have not even ever thought about this. How do you find a proof for yourself that you can be sure of? Rock solid proof, absolute certain proof, like proof that means truth, like the real proof. Well, that's what I found. And if anybody
you
else
have a
wants to
water
come and learn
level-
it, right, you can. You can come and discuss all of this with us at any point in
Bev,
time.
You have a water level tacked to your wall, right?
Yeah.
So you know it works.
Mm-hmm.
So why do you need to get a longer water level?
People keep saying, right, now, people keep saying, I'm not going to do the test. Now you're asking me why I need more, right? Because you're scared, I guess, that I might actually do this test. Oh, that I have already done the test.
I'm the last person who's going to be afraid of anything that you do.
Okay.
Okay.
Okay. So, are you asking? Why I'm doing the test? Then?
I've put flat earthers' claims to the test. I go out and I do this.
You flat earthers, right? So you, are you saying that I'm a flat earther, right?
If
you think this is a flat Earth claim,
a rose by any other name,
right? Okay, bearded. So
Then you're a
you
glober.
don't have a model. You don't have a model, right? You don't have a model, bearded, right? You don't have a model, but you say somebody who claims that level is a straight line on a horizontal plane is a flat earther.
Man.
That's a flat Earth claim, is it, bearded?
Bev.
Bearded, please answer the question. Do you think someone stating level is a straight line on a horizontal plane is a flat Earth claim? Do you think that?
It is a claim being made by a flat earther. Whether or
Who's
not
the flat earther?
Unless if you don't believe there's flat gravy.
It's three-dimensional. It is not
Gravy.
two-dimensional.
So then
know
what's the shape
now
then?
how
What's that three-dimensional shape?
the mountains and valleys, right? You can see it. There is an elevation change.
So the Earth is mountains and valleys. You're a mountain earther. Or a valley earther.
Are you the guy that doesn't have a model that are trying to ascribe a model to other people? Is that what you do? Is that your speciality? Bearded.
And valleys is just obfuscation. Is sandpaper flat?
Why do you have to label?
Sandpaper is flat, right? But it still has texture. It's still flat, though. You're still a flat Earth proponent and trying to, dodge that.
Level is horizontal is the claim, and there's a proof of a test.
Is sandpaper flat?
Bev, I talked about this yesterday.
He's saying sandpaper is not flat.
I know. Bev, I talked about this yesterday. Now, when you're saying level equals the flat Earth.
No, I do not say that. You guys say that. I say level is a straight line on a horizontal plane.
Okay, gravy.
And I have a proof
for
it.
The whole of the Earth. The whole of the Earth, right?
Will you guys stop getting obsessed with the Earth?
Can I?
You
can
guys
I
are crazy.
He's running
for 5 seconds.
Script. He's running off.
It's not an old script.
Cogdis script.
It's not cognitive dissonance.
It is. You group think, right? And group psychology is leading you
I can hold.
Yeah,
I can hold multiple contradictory concepts in my mind and not go crazy over it.
I bet you can.
You're a silly troll. You're a silly troll.
You understand that cognitive dissonance is the inability to hold conflicting information.
What?
You're a silly man.
Wow. You're proud of your contradictory information that you can hold.
No, I can still hold the concepts in my mind and not lose my mind. It's not complex.
This sounds like it. I've never seen this response before.
How many conflicting ideas are in there?
I have no idea. They're not labeled. Anyway, so the whole of the Earth is supposed to be level. Is that correct?
No, water level is horizontal. Level is also horizontal.
Yeah,
it's perpendicular
that's also what I said.
to the plumb
whole
line.
of the Earth. You want if you just want to wipe away the land,
wherever
you are,
water, wherever you are,
we can go with that.
Level will be horizontal. Yes, wherever you are.
Dude,
it will also always be perpendicular to
your tap dancing. I don't know why you're tap dancing.
He doesn't want to say the Earth is flat. He just wants to assert that
it's
all the
definitely
water.
it is definitely not flat. Flat is a
Okay.
two-dimensional object, right?
All right, Brian
Two-dimensional
Mabbott.
surface.
All right, Brian Mabbott.
Hey,
Who? Sorry, who's Brian Mabbott? Is he here?
You apparently.
What do you mean? No,
channeling
I'm
him.
definitely not Brian Mabbott. I'm Bev. Hello.
Yeah, because he thinks the water is level, then therefore the Earth is level and flat.
That's what I'm
water
saying.
level
Okay.
is horizontal. Yes, he's right in that regard.
Bev,
Absolutely.
Bev, why? Let's go with the simple concept. No land, only the oceans. Just say it. Just only the water. Since the land
Just
confuses
the water.
you, apparently.
Imagine water world.
Yes. The concept of water, the concept of land seems to cause a problem in your mind.
Yeah.
So let's go ahead and get rid of the land, and we'll just go with the Earth is water.
You're Kevin Costner, and you're Kevin Costner.
Yeah, I'm imagining it. Yeah.
Sure, why not? This is water world. Let's go.
Horizontal horizon all the way around us.
We got to go with something. Okay,
Mm-hmm.
so you got this water world or water plane or whatever. The plane of water. If you
sounds
know
good.
anything about
Sounds
Dungeons and
good.
Dragons, then that makes sense to you. Okay, so we have a water plane.
Yep.
All right, and it's a fine. Is it finite or is it infinite?
A plane. Should we look
No,
up
no,
the mathematical
this-
description of a
This
plane?
concept
Should
here.
we?
We're just going with water.
Yep.
And the Earth. We
And
have
a
a
plane.
water Earth.
You said a plane. Yeah.
Yes, it's
Okay.
still.
We'll
I'm
just go
asking
with a
real quick,
mathematical
is
definition
this-
of a plane. Should we?
Can you answer the question, or are you just going to
He
avoid the topic?
He doesn't know
I asked,
geometry, so he's
is
like,
it
you're
a
having a
finite
conversation with
plane?
someone that doesn't
And I'm
understand
not
what they're even talking
Bev.
about, Bev.
Mm-hmm.
Bev.
Yeah. Is a
You're
plane
having a
finite in mathematics? Bearded.
Which plane do you think I'm referring to?
I don't know. You took the plane that you decided your water plane was going to be in, right? That plane.
So if I just follow with me, is it? Well, I mean, even the Earth itself, is it finite? You did say it was 3 dimensions, and that does require finite parameters.
What? No. What? 3D requires
Three-dimensional
finite.
object has finite parameters. Yes.
Bev, you're having a conversation about geometry with someone that doesn't understand geometry.
I know,
This is
I
gonna
know,
be
but I mean,
difficult.
what you've noticed, Jeremy, you might notice that none of the other Globers are stepping up to
I'm
stop
not a
him
Glober, so that would
because
just be me and the Globers.
exactly.
No,
But what it means is they don't know that to shut you up either, right? They're
You're
quite
still
happy
not-
for you to embarrass yourself.
Why are you not addressing what I just said? You're going off and talking about other people. Bev, you said the Earth is a 3-dimensional object.
No, I
What
didn't
are
say
those-
that.
Yes, you did.
No, I said.
What, you're saying it's not?
What, a mountain?
Which is it,
Are you
Bev?
saying a
Either
mountain
the-
isn't 3-dimensional?
On what?
What do you mean on
As a
what?
surface,
Is it
it's still
3-dimensional or not? Just answer that one,
Compared
please.
to what?
Is it 3-dimensional or not?
Compared to what?
Oh, God.
Why would you
Compared
have
to,
to
compared to something that is 3-dimensional, or compare it to a pink elephant if you want, right? Is a mountain 3-dimensional compared to a
Is
pink
the
elephant?
mountain the whole Earth?
You don't need to compare.
I'm asking.
Yeah.
You're asking about a spot on the Earth. I'm asking about the entirety of the Earth.
And
The
I'm telling
plane is
you,
3-dimensional.
I'm telling you, a plane is not finite, right? There's no limits to it. So that's the way
Man.
you described your
A plane
water
can be
plane
fa- a-
at
a
the
plane can
beginning.
be
You asked
finite.
me to imagine something, and now you're suggesting that I'm not imagining it like you
Are you-
imagining
you're
it,
just gonna keep
right?
that
So
tap
he's
dancing.
saying we
Is
live
that-
on
is this
an
a problem?
plane.
Oh,
So
that's
he's
what I'm
saying we live
asking.
on an infinite plane.
Bev, are you saying that the Earth is an infinite plane?
I'm saying a plane, like you imagined at the beginning, mathematically has no edges, does it?
Wow.
Yeah, this is pointless. He cannot go off script.
What's the script, guys? Reality script.
Because that's not on the script. He's
Dude,
not prepared for that.
Dude,
So
this
I say
is
stick on that concept.
yeah.
Stick on
Okay,
that
guys.
topic.
All right.
In mathematics, a plane is a flat two-dimensional surface that extends infinitely far.
There you go. Infinitely.
Okay.
Not finite.
This is going to be extreme. Bev, this is going to be extremely difficult when you're trying to have a conversation about
It's
geometry.
not
when the
difficult.
other
I don't know
person
why
doesn't
everyone.
understand-
Why are you guys
the other
avoiding
person
that
doesn't
one
understand
question?
geometry.
Especially when Bearded keeps cutting people off. Right
Yeah,
when
I'm
he
gonna
asks
cut off
questions.
because I'm hearing about other shit.
Yeah, and then admitting that
and
he
you can
cuts people
cry
off.
in the fucking corner, Rakia, and suck a
It's just
dick,
aggravating.
dude.
You're just such a troll, man.
I don't
All
give
you're doing
a
is
fuck
wasting time. We
about
know.
your fucking
Why
Jose.
are you here?
you crybaby
care.
motherfucker.
Jose, is
Sit
this the
on a
way you
fucking
want this
pole
to
or
go?
something. I don't
Because
fucking know.
we don't really need to be here to deal with this. Because
This
like
ain't
Jeremy
this
says,
is the unmoderated portion, kiddo.
yeah, okay.
Congratulations.
All right,
dipshit.
but
Look
like
at
I
what
say,
the trolls are doing in the
like I say,
unmoderated
I
portion.
don't need to be here to talk to
Then go
geometrically
the fuck
illiterate
away.
people. Okay,
Take
right.
your pick.
See you later,
Either
guys.
you back
go
up your
over
fucking
I'm a
claims,
UK,
or you
right.
get the fuck out. That's not difficult.
There it is.
I gotta say, you're totally blowing my mind right now.
You twat. How do we know the Earth is not flat?
We don't. It's flat.
Well, we established that.
Of your understanding of the world in which you live, then of course the world looks flat. The world looks flat. The world looks flat.
Neil,
Bitch. You twat.
I gotta say, you're totally blowing my mind right now.
That's what I do. 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 What I do.
But I don't have much patience for anyone who denies that this challenge is real. We don't have time for a meeting of the Flat Earth Society. Flat Earth Society.
My friends, these people are so out of touch with science. You don't need to be a scientist to know that the Earth is round.
They must have been founding members of the Flat Earth Society. They would not have believed that the world was round.
Like water. Now you put water into a cup, it becomes the cup. You put water into a bottle, it becomes the bottle. You put in a teapot, it becomes the teapot. Now water can flow or it can crash.